Quieto parado. Quieto parado, pero nos viene Juanín. Quieto parado. Quieto parado, que nos viene Juanín. Sí, porque hasta la fecha, madre mía, no he catado nada. O sea que ya pueden sacar los juguetes ahora. Porque de momento no hemos catado nada. Y mira que llevan haciendo sesiones toda la santa mañana. Como lo oyes. Mañana viene el día potente, que es que está todo petado. Sesiones que se solapan unas con otras. Una cosa tremenda. Mañana tienes Boston Dynamics, Sanctuary. Y tienes también OpenAI, por supuesto, ¿vale? Y no tantas otras cosas. Atención, palabra clave de hoy. USD. No te puedo decir más. Pero vamos, la gente, madre mía, bastante monotonía, ¿eh? Porque se puede explicar de muchas maneras las cosas. Pero explicarlas de esta manera, con estos idiomas corporativos, aburridos, ya puede Juanín esmerarse, porque si no, mal asunto, ¿eh? Como lo oyes. Pensaba que había empezado, pero no. Esto empieza en punto. Sí, bueno, este es el típico escenario que al estilo 3D que tanto vamos a ver últimamente y tanto se ha visto ya en ciertas calles y avenidas de China, ¿vale? Porque aquí esto todavía no se ha visto suficiente, ¿vale? ¿Qué es el USD? Pues joder, el metaverso, escenas en 3D, ¿vale? Esto es de lo que se está hablando hoy en día, aquí. Estamos en el GTC 2024. Escenarios virtuales de ciberespacio. Que no, hombre, que esto es ciencia ficción todo. Míratelo. A ver, Juanín, no me seas aburrido como los que ya anteriormente han estado aquí. Porque madre mía.
Our show is about to begin.
Madre mía. Subtítulos, pues no lo tenemos, estamos aquí a pelo, que es lo gordo. Pero entonces vete tú aquí, porque te puedes ir aquí, yo en session, y aquí sí que tiene subtítulos. Pues lo vamos a hacer así mejor. Esto lo dejamos parado y esto lo dejamos en directo. Que sea lo que Dios quiera. ¿Aquí hay subtítulos? Que va, aquí tampoco. Pues no sé qué hacer, hijo. Lo tienes fastidiado. Lo tenemos en paralelo. Usted por aquí pare. Usted por aquí se reproduzca. I am AI 2024.
I am a visionary.
Soy un visionario. Instituto
Illuminating galaxies to witness the
Argón.
birth of stars.
Poca broma. Laboratorio Argón, Instituto de Ciencia,
Sharpening our understanding of extreme weather events.
agudizando nuestro conocimiento de los modelos meteorológicos.
I am a helper.
Soy un asistente,
Guiding the blind through a
guiando a los
crowded
ciegos por la
world.
calle hasta que llegue Neuralink, porque madre mía.
I was thinking about running to the store.
And giving voice to those who
Y
cannot
dando
speak.
voces a los que no pueden hablar. A ver si es verdad.
Do not make me laugh.
Pero esto ya
I
no es nuevo.
am a transformer.
Soy un transformador.
Harnessing gravity
Fábricas
to store
digitales,
renewable
modelos
power.
en 3D, duplicados digitales. No es ninguna sorpresa.
And paving the way towards unlimited clean
Universidad de
energy
Princeton,
for us all.
Estamos hablando de fusión nuclear. No llega nunca.
I am a trainer,
Soy un formador,
teaching robots to assist,
enseñando a los robots a asistir a los enfermos, pero que
to watch
sea
out
cierto,
for danger,
para vigilar en las instalaciones en busca de peligro. Boston Dynamics.
and help save lives.
Y ayudar a salvar vidas. Bueno, de esto podía hablar largo y tendido.
I am a healer,
Soy un sanador,
providing a new generation of
proveyendo
cures
de curas a una nueva
and
generación
new levels of patient care.
y nuevos
That I
niveles
am
de
allergic to
atención al
penicillin.
paciente.
Is it still okay to take the medications?
Definitely. These antibiotics don't contain penicillin, so it's perfectly safe for you to take them.
Estos antibióticos no contienen penicilina, o sea que podemos darlo. Soy un navegante. Construir calles
Generating virtual scenarios.
llenas de Londres, parece ser.
To let us
Muy
safely
bien, esto
explore
es mañana,
the real
¿vale?
world
Pero no vamos a dar abasto con todo. La conducción
and
autónoma ya ha habido
understand
sesiones.
every decision.
No damos abasto. Y además es que hay muchas sesiones que no se pueden ver.
I even
Muy mal.
helped
Este año muy
write
mal.
the
Hay
script.
unas sesiones que no he podido ver. De conducción autónoma.
Breathe life into the words en muchos idiomas y escribí la música.
Ahí va. Aquí anda que no hemos usado el IVA, ¿no? Anda, pero ya son años
I
ya,
am AI. Brought to life by NVIDIA, deep learning, and brilliant minds everywhere.
Please welcome to the stage NVIDIA founder and CEO Jensen Huang.
Juanin. Entre amigos. La chupa tiene su motivo, ¿eh? Esto es como el bemol.
Welcome to GTC.
Bienvenidos a GTC.
I hope you realize this is not a concert.
Esto no es un concierto, pero bien podía
You
serlo.
have arrived at a developers conference.
Habéis llegado a la conferencia de
There
los
will be a lot
desarrolladores
of
de NVIDIA.
science described, algorithms, computer architecture,
Algoritmos, computación,
mathematics.
arquitectura, computación, matemáticas. Esto no es un concierto, pero bien podría serlo. Esto es para frikis. Esto no mira aquí. Usted no
I
mire.
sensed a very heavy weight in the room all of a sudden.
Me siento
All
muy
of a sudden,
pesado
like
en la
you were in the wrong
ubicación de
place.
repente.
No conference in the world
No hay conferencia en el mundo
is there a greater assembly of researchers
que sea
from
tan
such
una
diverse fields of
una reunión
science
tan grande de
From
desarrolladores,
climate
de
tech.
científicos,
to radio scientists trying to figure out how to use AI to robotically control MIMOs
robótica,
for next generation 6G
telescopios,
radios,
científicos de todo
robotics,
tipo,
self-driving
medicina,
cars,
coches que se conducen solos, pero bueno,
even
¿esto qué es?
artificial intelligence,
Inteligencia artificial.
even artificial intelligence. Everybody's
No se puede aguantar, hombre.
first.
¿Qué ha pasado
I
aquí en el
noticed a
mundo,
sense
de
of
verdad?
relief there
Lo han vuelto
all
loco.
of a sudden. Also, this conference is represented
Esta
by some
conferencia
amazing
representa
companies.
Es representada por
This
muchas
list-
compañías. Pues fíjate,
this is
todas las
not the
compañías que hay aquí, pues se
attendees.
han sumado todos al carro ahora a lo que,
These
a lo
are
que lo
the
peta.
presenters.
Tú vete hace
what's
4 o 5
amazing
años
is
a ver
this.
lo que había por aquí, ¿vale?
If you take away
Eso
all
lo
of
digo
my
yo.
friends, close friends,
Mira,
Michael Dell is
Stellantis,
sitting right there,
Runway,
in the IT industry,
Pixar. De Pixar se puede hablar muy largo y tendido.
all of the friends I grew up with in the
Todos los amigos
industry.
con los que he
If you
crecido en la
take away
industria.
that list, this is what's amazing.
Esto es lo que es sorprendente.
These are the presenters of the non-IT industries using accelerated
Son
computing
representantes de la
to
tecnología de
solve problems that normal
industrias no
computers can't.
tecnológicas, ¿vale?
It's represented in life sciences, healthcare,
Pero
genomics,
también tienes genómica,
transportation, of
ciencias de la
course,
vida,
retail,
hasta el ejército.
logistics,
Northrop
manufacturing,
Grumman creo que
industrial.
sale mañana. Eso lo digo yo.
The gamut of industries
La gama de
represented
industrias
is truly amazing.
es
And you're not here to
sorprendente.
attend only, you're here to present.
Si estáis aquí para
Talk
presentar.
about your research.
Aquí necesitamos demos, hay que
$100
presentar
trillion
cosas.
of the
Eso lo digo
world's
yo.
industries is represented in this room today. This is absolutely amazing.
Sorprendente. Y de momento demos no he visto
There is
ninguna, ¿eh?
absolutely something happening. There
Algo
is something
asombroso está
going on.
sucediendo.
The industry is being transformed,
La industria
not
está siendo
just
transformada.
ours.
No por
Because the
nosotros.
computer industry The computer
Por la-
is the single most
La
important instrument
computadora
of
es el
society
instrumento
today.
más importante de la industria hoy
Fundamental
en día.
transformations in computing affects every
Las
industry.
transformaciones en la computación
But how did we
afectan a
start?
toda
How
la
did we get
industria.
here? I made a little cartoon for you. Literally, I drew this.
Tengo aquí
In
un
one
dibujo para
page,
vosotros.
this is NVIDIA's journey.
Esto es el
Started in
desarrollo de Nvidia.
1993.
Desde el
This might be the
64
rest of the
IBM.
talk.
Primer contacto, AlexNet, 2012.
1993. This is our journey. We were founded in
2022
1993. There are several
ChatGPT,
important
hombre,
events that happened
fíjate.
along the way.
Y luego, ¿qué
I'll
más?
just highlight a few.
Revolución industrial.
In
Una nueva
2006,
revolución industrial,
CUDA,
startups,
which has turned out to have
crecimiento
been a
exponencial,
revolutionary computing model,
alineamiento,
we thought it was revolutionary then.
IA
It
generativa,
was going to be an
etcétera, etcétera.
overnight success, and almost 20 years later, it happened. We saw it coming.
Lo vimos venir.
2 decades later.
2 décadas después,
In 2012, AlexNet,
AlexNet,
AI, and CUDA made
inteligencia
first
artificial y
contact.
CUDA.
In 2016,
2016.
recognizing the importance of this computing model, we invented a brand new type of computer.
Inventamos un
We
nuevo
called
tipo
it
de computación.
DGX-1.
DGX1,
170 teraflops in this supercomputer. 8 GPUs connected together for the
170
very first time.
teraflops en cada
I hand-delivered
computadora.
the very first DGX-1 to a startup located in San Francisco
localizada en San Francisco,
called OpenAI.
OpenAI.
DGX-1 was the world's first AI supercomputer. Remember, 170 teraflops. 2017,
170
the
teraflops.
transformer arrived. 2022, ChatGPT captured the world's imaginations. Have people
ChatGPT,
realize the
bueno, que cambió el
importance and the
mundo.
capabilities of artificial
Pues sus
intelligence.
capacidades de
In
inteligencia artificial.
2023, generative AI
En 2023
emerged
la IA generativa
and a new
emergió,
industry
pues con todo lo que
begins.
sabemos ya.
Why? Why is a new
¿Por qué?
industry? Because the
Porque es una
software
nueva
never
industria.
existed before.
Porque no
We
existía
are now
antes.
producing software,
Estamos
using
produciendo
computers
software.
to write software, producing software that never existed before.
Que
It
nunca
is a
existía
brand new
antes.
category. It took
No,
share
una
from
nueva
nothing.
categoría totalmente nueva.
It's a brand new category. And the way you produce this software
Y la manera en que produces este software
is unlike anything we've ever done
no es como
before.
nada que hemos hecho
In data
antes.
centers,
En centros de datos,
generating tokens,
generando tokens,
producing
produciendo
floating point numbers
números de punto
at
flotante
very large scale.
a mucha gran
As
escala.
if, in the
Exascala.
beginning of this last industrial
Al principio de
revolution,
esta revolución
when
industrial
people
nueva,
realized that you would set up factories, apply energy to it,
hay que aplicar
and
energía
this
a
invisible,
a
valuable
las
thing called
factorías
electricity came out. AC generators.
y están los generadores
And 100 years later, 200
Hace-
years later, we are now
y después
creating new types of
ahora
electrons,
estamos creando un nuevo
tokens,
tipo de electrónica
using infrastructure we call factories, AI
usando
factories, to
las
generate
fábricas llamadas
this
fábricas
new,
de IA,
incredibly valuable thing
que son muy
called
valiosas
artificial intelligence. A new
porque
industry
crean
has
inteligencia,
emerged.
generan inteligencia.
Well, we're going to talk about many things about this new industry.
Podemos hablar mucho sobre
We're
esta
going to
nueva
talk about how
industria.
we're going to do computing next.
¿Cómo hacemos
We're going
ahora
to talk
la
about the
computación?
type of software that you build
El nuevo
because of
software
this
que
new industry.
construís.
The new software. How you would think about this new software.
¿Qué
What about
pensáis de este nuevo
applications in this new
software?
industry? And then maybe what's next?
¿Qué
And
viene
how can
después?
we start preparing today
¿Cómo nos
for what's
podemos
about
empezar a
to come
preparar para lo que
next?
viene después?
Well, but before I start,
Pero antes de que empiece,
I want to show you
quiero mostraros
the soul of NVIDIA, the soul of our company. At the
el
intersection
alma de nuestra compañía.
of computer graphics,
Gráficas de computadores, para los jueguitos
and
de los
artificial
niños, y
intelligence.
cojones, y de mayores.
all intersecting inside a computer in Omniverse,
Y
in a
Omniverse, ¿qué
virtual world
significa esto?
simulation.
Simulaciones de realidad
Everything we're
virtual.
going to show you today,
Es lo que os
literally
voy a
everything
enseñar
we're going
hoy.
to show you today, is a simulation, not animation.
Simulación,
It's
no
only beautiful
animación.
because it's physics.
Es
The
nuevo
world is
porque esto
beautiful.
es física y es muy
It's only
bonito.
amazing because it's
Sorprendente
being animated with robotics.
porque ha sido animado
It's
por
being
robótica.
animated with artificial intelligence.
Con inteligencia
What you're
artificial.
about to see all day is completely generated completely
Lo que vais
simulated
a ver hoy
in Omniverse.
está completamente
And all
simulado
of
con
it,
Omniverse.
what you're about to enjoy is the world's first
Lo que vais
concert
a disfrutar
where
es,
everything is homemade.
todo está hecho en casa.
Everything is homemade.
Todo está hecho aquí.
You're about to watch some home videos.
Vais a
So
ver
sit
vídeos
back
caseros,
and enjoy yourself.
sentados y relajados. Adobe, Autodesk, Shutterstock. Al fin y al cabo, Nvidia es una industria muy visual, pero es que hay mucho más ahora. Es que lo de USD vais a flipar. O sea, vais a flipar. Es la idea que tengo yo, que igual al final termina haciendo de otra manera. Física. Esto siempre ha ido de física, en Nvidia, ¿verdad? Leyes naturales de todo tipo. Simulación de leyes naturales, de leyes físicas. Al fin y al cabo es eso. Estamos creando otro universo. Metaverso. Tejidos, cómo se doblan. Todo es simulable, todo es computable, todo es programable. Es que los robots son muy torpes, digo, sí. Ya llegará. Entonces, ¿qué le ha parecido lo de Figure One? Porque el cambio va a ser exponencial, ¿vale? Dobles digitales de todo, de barcos, de industrias, de personas. Claro, es que las vacunas de ARN mensajeros se han hecho con dobles de personas, ¿vale? Ya está. Simuladas, simulaciones. Al fin y al cabo, ¿qué son? ¿Qué es este mundo? Al fin y al cabo, ¿no? Bueno, eso es todo discutible. La autónoma está ya, está ya. Tierra 2.0. Tierra 2.
God, I love NVIDIA.
Me encanta Nvidia.
Accelerated computing
Computación
has
acelerada.
reached the tipping point.
Ha llegado al punto
General
culmen.
purpose computing has run out of steam.
La proposición de
We need
propósito
another
general.
way of doing computing so that we can continue to scale, so that we can continue to drive
Continuamos
down the cost of
escalando,
computing, so that
llegando a la
we can
cúspide.
continue to consume more and more computing while being sustainable.
Consumiendo más
Accelerated
computación, pero siendo
is a
sostenibles.
dramatic speed up over general purpose
Está
computing.
acelerando
And
la
in
computación
every single
general.
industry we engage, and
Acelerada.
I'll show you many, the impact is dramatic.
El impacto es
But in
dramático.
no industry is it more important than our own.
Ninguna
The
industria es más
industry
importante que la
of
nuestra.
using simulation tools,
Usando
create
herramientas de
products.
simulación,
in
creamos
this
modelos.
industry, it is not about driving down the cost of computing, it's about driving up the scale of computing.
Hablamos de
We would
escala.
like to be able to simulate the entire product that we do
Puedes
completely
simular el
in full
completo
fidelity,
producto que
completely
hacemos
digitally,
y
and
remodelarlo
essentially what we
digitalmente
call digital twins.
con
We would
dobles
like to
digitales.
design it, build it,
Diseñarlo,
simulate
construirlo,
it, operate it,
simularlo, operarlo. Siempre en el
completely
ciberespacio.
In order to do that, we need to accelerate an entire industry. And
Aceleraremos
today,
la
I would
industria.
like to announce that we have some partners who are joining us in this
Tenemos
journey
algunos compañeros que nos
to
unirán
accelerate
a
their
nosotros en este
entire
viaje
ecosystem so that we can bring the world
para brindar a
into
este mundo
accelerated computing.
una computación
But
acelerada.
there's a bonus.
Pero hay un
When you
bonus.
become accelerated,
Cuando te
your
aceleras,
infrastructure is CUDA GPUs.
la
And when that
infraestructura
happens,
es
it's
los
exactly
GPUs
the
de
same
CUDA.
infrastructure for generative AI.
Y se usará para
And so I'm
la
just
IA
delighted
generativa.
to announce several very important partnerships.
Vamos
There
a
are some of the
anunciar
most
varias
important
colaboraciones.
companies in the world. ANSYS does engineering simulation for what the world makes. We're partnering with them
ANSYS?
to CUDA accelerate the ANSYS ecosystem, to connect ANSYS to the Omniverse digital twin.
Conectará al
Incredible.
doble digital del
The thing that's
universo.
really great is that the install base of NVIDIA GPU accelerated systems are all over the world, in every cloud,
En
in
todo el
every
mundo,
system,
en cada nube, en cada
all over
sistema.
enterprises.
En
And
cada
so
empresa.
the applications they accelerate will
Las
have a
aplicaciones que
giant install
aceleran.
base to go serve. End users will have amazing applications.
Los usuarios
And of
tendrán
course,
magníficas
system makers and
aplicaciones.
CSPs will have great customer demand.
Y supondrá una demanda de un cliente muy intensa.
Synopsys is NVIDIA's
Synopsys.
literally first software partner. They were
Primer
there
compañero de
in the
software
very
de
first day of
NVIDIA.
our company. Synopsys revolutionized the chip industry
Revoluciona la
with
industria de
high-level
los
design.
chips
We
y
are
el
going
diseño.
to CUDA accelerate Synopsys.
CUDA
We're
acelera
accelerating
a
computational
Synopsys.
lithography, one of the most important applications that nobody's
Una
ever
de
known
las
about.
grandes
In order
aplicaciones
to
que,
make
de las que nadie
chips,
sabe.
we have to push
Litografía me
lithography to a limit.
parecido entender.
NVIDIA has created a library, a
NVIDIA
domain-specific
ha creado
library
una librería
that
específica
accelerates computational
que
lithography
acelera
incredibly.
la computación
Once we
increíblemente.
can accelerate and software-define all of TSMC, who is announcing
TSMC, la
today
famosa fábrica
that
que
they're
todo el
going to
mundo ya
go
tiene
into
que conocer
production
en
with
Taiwán,
NVIDIA
evidentemente.
cuLitho. Once it's software-defined and accelerated,
Taiwán,
the next step
Holanda, ¿no?
is to
Es
apply
también.
generative AI to the future of semiconductor manufacturing,
Para el
pushing
futuro de la
geometry even
industria
further.
de los semiconductores.
Cadence builds the
Cadence.
world's essential EDA and SDA tools. We also use Cadence.
Herramientas,
Between
EDA
these
y
three companies,
SDA, no
ANSYS,
sé qué
Synopsys,
significa
and
eso.
Cadence, we basically build NVIDIA. Together, we are CUDA accelerating Cadence. They're also building a supercomputer out of
Parecido ver
NVIDIA
que es
GPUs
biomédico, creo yo.
so that their customers could do fluid dynamic simulation
Nuestros
at 100,
clientes podrán hacer
1,000 times
simulaciones
scale.
a mucha mayor
Basically,
escala.
a wind tunnel in real time. Cadence Millennium, a supercomputer with NVIDIA GPUs
Una
inside.
supercomputación con
A software
los
company
GPUs de
building
NVIDIA
supercomputers.
adentro.
I love seeing that.
Me encanta
Building
verlo.
Cadence co-pilots together. Imagine a
Cadence
day
y NVIDIA copilotean juntos.
when Cadence could, Synopsys, ANSYS,
Cadence,
tool providers
Synopsys, ANSYS,
would
ANSYS.
offer you AI co-pilots so that we have thousands and thousands of co-pilot assistants
Cientos y
helping us
cientos de
design
asistentes
chips, design
de
systems.
copilotaje.
And we're also going to connect Cadence Digital Twin Platform
Vamos
to Omniverse.
a conectar
As you can
a
see the
Omniverse
trend here,
la
we're
plataforma de
accelerating
Cadence.
the world's CAE, EDA, and SDA so that we could create our future in digital twins.
Que haremos
And we're going
nuestro
to
futuro
connect
en
them all to
dobles
Omniverse,
digitales.
the fundamental operating system for future digital twins.
El sistema operativo de los futuros
One
dobles
of the
digitales.
industries that benefited tremendously from scale,
Bueno,
and
esto está
you all
hablando de
know
la
this one
computación de
very well,
entrenamiento de los
large
modelos
language
LLM,
models.
por lo que veo.
Basically, after the transformer was invented,
Después de que el Transformer fue
we were able to
inventado,
scale large
hemos
language
sido
models
capaces de
at
escalar
incredible rates,
los LLMs
effectively
a
doubling every 6
gran
months.
proporción. A
Now,
gran
how is it possible that by
¿Cómo es
doubling
posible?
every 6 months, that we have grown the industry, we have grown the
Que hemos hecho crecer la
computational
industria cada 6
requirements so
meses?
far? And the reason for that is quite simply this.
La razón es muy
You double
simple.
the size of the model, you double the size
Doblando
of your
la-
brain, you
el
need
tamaño
twice
del
as much
modelo
information to go fill it. And
doblando la
so every
computación.
time you double
Cada vez que
your
doblas,
parameter count, you
el pa-
also have
el
to
conteo de parámetros
appropriately increase your training
se mejora
token count.
el
The
entrenamiento
combination of
del
those two
modelo.
numbers becomes the computation scale you have to support. The latest, the
Necesitas
state-of-the-art OpenAI
escalar
model
y para eso, claro, está
is
NVIDIA.
approximately
evidentemente.
1.8 trillion
Necesitas más
parameters.
potencia.
1.8 trillion parameters required several trillion tokens to go train.
Varios trillones de
So
tokens que
a few
necesitas
trillion
entrenar.
parameters on the order of, a few trillion tokens on the order of,
Unos
when you
pocos
multiply the two of them
trillones,
together, approximately 30,
Aproximadamente
40, 50
30, 40, 50,
billion, quadrillion
1000 millones o
floating point
o
operations per
cuatrillones.
second. Now we just have to do some CO math right now. Just
Se
hang,
me ha explotado la
hang
cabeza,
with
por
me.
favor.
So you have 30
Cuatrillones, ¿qué es eso?
billion
¿Qué número es
quadrillion.
ese?
A quadrillion is like a peta.
Un cuadrillón
And so
es
if you had a petaflop
como es como un
GPU,
petaflop.
you would need 30
Necesitarás
billion seconds
30
to go
mil
compute,
millones de
to go train that
segundos
model.
para
30
computar,
billion
para entrenar ese
seconds is
modelo.
approximately 1,000 years.
1000 años.
Well, 1,000 years
Pero bueno, ¿para qué queremos la
it's
computación
worth
cuántica,
it.
verdad?
like to do it sooner, but it's worth it.
Podemos hacerlo más pronto, pero merece la pena.
Which is usually my answer when most people tell me, hey, how long is it going to take to do something? So we get 20 years?
20 años
worth it.
tardaremos en hacerlo. ¿Merecerá la pena?
But can we do it next week?
¿Podemos hacerlo la próxima semana?
And so, 1,000 years. So
1000
what
años.
we need are bigger GPUs.
Necesitamos, por tanto, más
We need
GPUs más
much bigger
grandes.
GPUs. We recognized this early on. And we realized
Reconocimos esto
that
muy
the
pronto.
answer is to put a whole bunch of GPUs
La
together.
respuesta es ponerlos
And
juntos
of
en
course,
paralelo.
innovate a whole bunch of things along the way, like
En
inventing
racks.
tensor cores,
Ahí tienes los H100 y los A100.
advancing NVLink so that we could create essentially virtually giant GPUs,
Puedes crear gigantes
and connecting
GPUs
them all together with amazing networks
conectándolos con
from a company called
maravillosas redes
Mellanox, InfiniBand, so that we could create these giant
InfiniBand
systems.
para crear estos
And so
maravillosos sistemas.
DGX1 was our first version, but it wasn't the last. We
Esa fue nuestra
built
primera versión, pero no
supercomputers
fue la
all the
última.
way, all along the way.
Y
In
seguimos mejorando.
2021, we had Selene, 4,500
Tenemos
GPUs
Selene.
or so.
En el
And then
2021.
in 2023,
4480
we built one of the
A100.
largest AI supercomputers in the world. It's just come online, EOS.
iOS.
And as we're building these things,
2023, que es todavía
we're
mejor que
trying to
los
help the
H100, que
world
esos son
build
los,
these things.
no son los
And in
hoppers.
order to help the world build these things, we got to build them first. We build the chips, the systems,
Construimos los
the
chips, los
networking,
sistemas,
all
la
of the
red.
software necessary to do
Software
this. You
necesario.
should see these systems. Imagine writing a piece of software that runs across the
Imagínate
entire
escribir
system, distributing the
un pedazo de
computation
software
across thousands of GPUs, but inside are
con
thousands of smaller GPUs.
Miles de GPUs dentro, más
Millions of GPUs to
GPUs
distribute
dentro.
work across all of that,
Distribuidos
and to
por
balance the
todo.
workload so that you can get the most energy efficiency,
Y son
the best
eficientes
computation
energéticamente, claro.
time, keep your costs down. And so
Permiten mantener los costes
those
moderados.
fundamental innovations
Son innovaciones
is what got us
fundamentales
here.
que nos han traído hasta
And
aquí.
here we are,
Y aquí estamos,
as we see the miracle of
viendo el milagro
ChatGPT
de
emerge in front of
ChatGPT
us, we
enfrente
also
de
realize
nosotros.
we have a long ways to go.
Tenemos mucho
We
todavía
need
que hacer.
even larger models.
Incluso
We're
modelos
going to
más
train it with
grandes.
multimodality data, not just
Con
text
datos de
on the
multimodalidad,
internet.
no
but
solo
we're going to
texto.
train it on text and images and graphs and
Imágenes,
charts.
gráficos.
And just as we learn watching TV.
Y
And
podemos
so
ver la
there's going to be a whole
televisión.
bunch of watching video so that these
Y vídeos.
models can be
Estos modelos
grounded in physics, understands that
Pueden
an
estar
arm doesn't go through a
aterrizando,
wall.
tienen
And
datos
so
de
these
física
models would have common sense
y tienen
by
sentido común.
watching a lot of the world's video combined with a lot of the world's languages.
Datos de vídeo, datos
They'll
de
use things like synthetic
idioma.
data generation, just as you and I do. When we try to learn,
Hace
we
como tú
might
y yo
use our
cuando aprendemos.
imagination to simulate how it's going to end
Simular
up, just as I
¿Cómo
did when I
va a
was
resultar
preparing for
algo?
this keynote.
Son modelos predictivos.
Simulating
¿Cómo va a
it all
resultar
along the way.
esta keynote? Pues también me lo he pensado yo.
I hope it's going to turn out
Espero que vaya bien.
as well as I had it in my
También
head.
como tenía yo en la mente. ¿No ves? Si es que somos modelos predictivos. Es que ustedes tampoco están una cosa tan especial. Es que esta gente no piensa, estos
As
máquinas
I
no
was
piensan. Digo, ¿pero
simulating how
usted qué
this keynote
piensa?
was going to
Entonces,
turn out, somebody did say
usted igual podemos decir
that
que tampoco
another
piensa mucho. Y hay
performer
gente por ahí que la verdad es que muy poquito. Eso lo digo yo.
did her performance completely on a treadmill so that she could be in shape to deliver it with full energy. I didn't do that.
Esto lo he
If I
entendido.
get a little winded about 10 minutes into this, you know what happened. And so where were we?
¿Dónde estamos ahora?
We're sitting here using synthetic data generation. We're going to use reinforcement learning. We're going to practice it in our mind. We're going to have
aprendizaje
AI
reforzado.
working with AI, training each other, just like
Entrenando
student and teacher
IAs entre ellos,
debaters.
estudiando con
All
sus
of that is
modelos
going to
más
increase the size
anteriores.
of our model. It's going to increase the amount of data that we have,
Incrementará la
and we're
cantidad
going
de
to have
datos
to
que
build
tenemos.
even bigger GPUs.
Con GPUs cada vez más
Hopper
grandes.
is fantastic,
Esto es fantástico.
but we need bigger
Pero
GPUs.
necesitamos GPUs más
And
grandes.
so, ladies and gentlemen,
Y así que, señoras y señores,
I would like to introduce you
me gustaría introduciros a otro cacharro que me va a
to
traer
a
por aquí.
very, very big GPU.
Otro GPU muy grande. Esto es lo que va. De esto va el tema. De traer aquí el cacharrón este. Que ahora lo vas a tener que traer con una carretilla, probablemente.
Named after David
Esto no
Blackwell,
son gráficas como las nuestras, de los usuarios.
mathematician, game theorists, probability.
Teórico de juegos,
We thought it was a
matemático.
perfect name. Blackwell, ladies and
Blackwell.
gentlemen, enjoy this.
Disfrutad de esto. Otra gráfica, otro chip, Blackwell. El más grande chip Físicamente posible. Los dos grandes, mejor dicho, unificados como uno. Blackwell versus Hopper. Bueno. 120 billones de computación, en billones en americanos, claro. El motor de la nueva revolución industrial. 20 petaflops de ejecución de IA. Esto no me llama la atención suficiente. Construyendo bloques del GB200 super chip. No sé qué coño es esto. No sé qué coño es esto, de verdad. Yo lo quiero para mi ordenador, no se puede. 40 petaflops. Que hay otras variantes. El nodo de computación más poderoso nunca creado. Pues tienes más. Con una conectividad de InfiniBand, no sé qué tal. Los metes ahí, o sea, chips dentro de chips, dentro de chips, dentro de Bluefield 3 DPU. Poderoso procesador e infraestructura. Todo metido en los racks. GB200NVL72, computación para el moderno centro de datos. Un NVLink Switch, Blackwell Multi GPU Fabric. NVLink Switch System, Blackwell Multi GPU Fabric, es lo mismo. Si metes más, pues cuanto más mejor. Un masivo GPU para la IA generativa, para entrenar modelos. Quizás la AGI, hombre, igual llega la AGI con esto. Pues si no llega la AGI con esto, te va a dar igual, porque... Bueno, me callo. Pues yo es que ya he perdido la cuenta, ¿verdad? Networking para la... Fíjate. ¿Y con esto qué ventilador necesitas? Pues 2 por reduce rack cooling system, no sé qué. Pero hay más todavía, pero ¿Esto qué coño es, tío? ¿Dónde metes esto? Esto es una fábrica entera. Completo, centro de datos con 32.000 GPUs. Una factoría de IA. ¿Vale? Próximamente en un lugar muy cercano a usted.
Blackwell is not a chip.
Blackwell
Blackwell is
no
the
es un
name of
chip.
a platform.
Es una plataforma.
People think we make GPUs.
Gente piensa que hacemos
and
GPUs.
we do.
Y eso es lo que hacemos, pero
But
hay más.
GPUs don't look the way they used to.
No parecen como las eran antes,
Here's
Esto ha cambiado mucho,
here's the,
Esto es la gráfica que
if you
tengo
will,
metida en mi
the heart
ordenador.
of the
Esto es otra
Blackwell
cosa.
system. And this inside the company is not called Blackwell, it's just a number.
Es un número dentro de la compañía.
This is Blackwell
Esto es
sitting
Blackwell.
next to, this is the most advanced GPU in the world in production today.
El chip más avanzado que existe en el mundo hoy en día. Tú la llevas.
This is Hopper.
Y esto es Hopper.
This
Que
is
no está mal. A
Hopper.
mí dame un Hopper,
Hopper
también, que no
changed
está
the
nada
world.
mal. Pero bueno, pues ya se ha pasado de moda.
This
Esto es
is
exponencial,
Blackwell.
claro. De eso va el tema. Es más pequeño, además. ¿Cómo lo ves?
It's okay, Hopper.
Es ok, Hopper. No pasa nada. A mí dame Hopper, no te preocupes. Me conformo.
You're very good.
Este eres muy bueno. Sí, como el GPT chat, ¿no? O como el GPT-3. Ahora no se acuerda nadie, pobrecito mío.
Good girl.
Acabo de oír a Sam Altman. Cuando llegue el GPT-5, el GPT-4 será el
208 billion
GPT-3.
transistors. And so you
Y
can
no
see,
nos acordaremos.
I can see there's a small line
Qué
between two
tristeza la
dies. This is the
depreciación, de
first
verdad.
time two dies have abutted like this together in such a way that the two dies think it's one chip.
Las dos caras
There's
piensan que
10
es un chip
terabytes of data between it. 10 terabytes per second.
por segundo.
So that these two sides of the Blackwell chip have no clue which side they're on.
Estas dos caras no saben en qué
There's no
lado
memory
están.
locality issues, no cache issues. It's just one giant chip.
Es solo un
And
único
so,
chip.
when we were told that Blackwell's ambitions were beyond the limits of physics,
Las ambiciones de Blackwell están más
engineer
allá de
said,
los
"So what?"
límites de la física.
and so this is what happened.
Esto
And
es
so
lo que
this
pasa.
is the Blackwell chip, and it goes into
¿Cuánto cuesta?
two types of systems. The first one
Dos tipos de chips.
is form-fit function compatible to Hopper.
El primero
And
es
so you
comparable
slide
a
out
Hopper.
and you push in Blackwell.
Lo
That's the
metes
reason
ahí.
why one of the challenges of ramping is going to be so efficient. There are
Va a ser muy
installations
eficiente.
of Hoppers all over the world, and they could be the same infrastructure, same design,
Misma infraestructura,
the
mismo
power, the
diseño,
electricity, the
potencia,
thermals,
electricidad,
the software,
software.
identical, push it
Idéntico.
right back. And so this is a Hopper version for the current
Versión
HGX
Hopper
configuration.
para la nueva
And this is
actualización, la
what
configuración.
the second Hopper looks
Segundo
like this.
Hopper.
Now this is a prototype board.
Un
And,
tablero, una
Janine,
placa de
could I just
prototipo.
borrow? Ladies and gentlemen, Janine Paul.
Señoras y señoras, aquí tienes. La chica no importa, lo que importa es el bicharraco.
And so this is a fully functioning board, and I'll just be careful here.
Cuidado aquí, no se te caiga, por favor.
This
Como
right
más
here
quieras.
is, I don't know,
Parece un señor.
$10 billion.
10 billones de dólares, ¿vale? 10.000 millones de dólares.
The second
Cuidado.
one's 5.
Mira que si se te cae.
It gets cheaper after that. So any customers in the audience, it's okay.
Está bien.
All right, but this one's quite expensive. This is the bring up board.
Esto
And,
es muy caro.
and the way it's going to go to production is like this one here, okay?
El que
And
va
so
a
you're going
producirse es
to
este de aquí.
take this. It has two Blackwell
Dos-
Blackwell chips
dos
and
chips
4 Blackwell
Blackwell
dies connected to a Grace
con
CPU.
un-
The Grace CPU
conectado
has
con
a
un chip
super
C-
fast chip-to-chip link. What's
Grace.
amazing is this computer is
Este
the
computador
first of its kind
es el primero de
where
su clase-
this much
clase.
computation, first of all, fits into this small of a place.
Encaja
Second,
muy
it's
fácilmente.
memory coherent. They feel like they're just one big happy family working on one application
Va a ser una
together.
familia feliz
And so
trabajando en
everything
una
is
aplicación.
coherent
No sé.
within it. Just the amount of, you saw the numbers. There's a lot of terabytes this and terabytes that.
Muchos terabits
But
por ahí.
this is a miracle. This is a
Esto es un milagro.
let's see, what are some of the things on here? There's NVLink on top,
Link arriba,
PCI Express on the bottom,
PCI Express abajo.
on your, which one is mine and your left? One of them,
Es
it
mi
doesn't
izquierda y
matter.
cuál es mi derecha.
One of them is a
¿Cuál es nuestra
CPU
izquierda y cuál es
chip-to-chip
nuestra
link.
izquierda?
It's my left or your, depending on which side.
A mi
I was
izquierda.
I was trying to sort that out, and I just kind of, doesn't
igual.
matter.
No pasa nada.
Hopefully it comes plugged in, so.
Espero que se conecte.
Okay, so this is the Grace Blackwell system.
Este es el Grace Blackwell System, ¿vale?
But there's more.
Pero hay más. Esto siempre ha habido de
So
hardware.
it turns out,
Resulta,
all of the specs is fantastic, but we need a whole
todo es
lot of new
fantástico,
features.
pero necesitamos
Uh,
más
In order to push the limits
características
beyond,
para
if you will, the
forzar
limits
los
of physics.
límites más allá.
We would like to always get a lot more X factors.
Necesitamos más
And
factores.
so one of the things that we did was we invented another transformer engine,
Hemos
another
inventado
transformer engine, the second
otro motor
generation.
transformativo
It has the ability to dynamically
que tiene la capacidad de
and
dinámicamente
automatically rescale
rescalar
and recast
y recast... No, eso no sé qué es.
numerical formats
En
to a
formatos
lower
numéricos,
precision whenever it can.
cuando
Remember,
pueda.
artificial intelligence is about probability.
La IA sobre,
And so
la IA
you
sobre,
kinda
va sobre las
have,
probabilidades.
1.7, approximately
1.7
1.7 times approximately
aproximadamente
1.4 to be
1.4
approximately something else. Does
algo
that make
más.
sense? And so the ability for the mathematics to
La habilidad para las
retain
matemáticas
the precision
de
and
mantener
the
la
range
precisión
necessary
cuando
in
sea
that
necesario
particular stage of the pipeline, super important.
Es muy
And so
importante.
it's not just about the fact that we designed a smaller ALU. It's
No
not
solo
quite, the world's
diseñar
not quite that simple.
algo más pequeño.
You've got
Eso es
to
simple.
figure out when you can use that
Tienes que descubrir
across a
cuándo usar eso.
computation that is thousands of GPUs.
Y
It's running for
una
weeks and weeks
computación
on
que son
weeks, and you
cientos
want to
de
make sure
GPUs.
that the training job is going to converge.
Y asegurarnos
And so
que el-
this
el
new
trabajo de
transformer engine,
entrenamiento
we have
va
a
a
fifth
converger.
generation NVLink. It's now twice as fast as Hopper,
El
but very
NVLink es
importantly,
más rápido que
it has
Hopper.
computation in the network.
Y tiene la
And the reason
computación
for
en
that
la
is because
red.
when you have so many different GPUs working together,
tienes tantos GPUs
we have to
trabajando
share
juntos, tienes que
our
compartir
information with each other.
la información
We have to
con ellos
synchronize
mismos.
and update each other.
Y
And every
actualizarse
so
entre ellos
often,
mismos.
we have to reduce the partial products
Tienes que
and then
reducir-
rebroadcast out the partial products, the sum of the partial products, back to everybody else.
Eso lo he
And so
entendido.
there's a
Entre
lot of
ellos,
what is
digamos,
called
la
all
señal, creo
reduce
yo.
and all to all and all gather. It's all
Todos se
part of this
reúnen
area of synchronization and
de una área de
collectives so that we
sincronización
can have GPUs working with each other.
en la cual los
Having
GPUs trabajarán unos con
extraordinarily
otros.
fast links and being able to do mathematics right in the
Poder hacer
network
matemáticas en la
allows us
red
to essentially amplify
para
even
amplificar
further. So even
mucho
though it's
más.
1.8 terabytes per second,
1.8
it's effectively higher
terabytes
than
por
that.
segundo
And so it's many times that of Hopper.
es
The
mucho más veces más que
likelihood
Hopper.
of a supercomputer running for weeks on end is approximately zero. And the reason for that is because there's so many components working at the same time.
Hay muchos componentes que
The
trabajan a la misma vez.
statistic, the probability of them working continuously is
La
very low.
probabilidad es que trabajen
And so we
juntos
need to
en
make
tanto
sure that
tiempo es muy
whenever there
difícil.
is we checkpoint and restart as often as we can.
A veces sí que podemos
But
reiniciar,
if
pero
we have the ability to detect
tenemos la capacidad de
a
detectar
weak chip or a weak node early,
chip débil,
we can retire it and
retirarlo
maybe
por su
swap
cuenta
in
y
another
sustituirlo por otro
processor. That
nuevo.
ability to keep the
Esta
utilization
capacidad
of the
de mantenerlo
supercomputer high,
continuo, activo,
especially when you
especialmente
just spent
cuando
$2 billion building it,
tienes
is
un edificio de
super
no sé
important.
cuántos millones de
And
dólares.
so we put in a RAS engine, a reliability engine that does
Tienes un motor
100%
RAS
self-test,
que
in-system
puedes generar un
test
subtest
of every
en el sistema,
single gate,
en
every
cada puerta,
single bit of memory
en cada bit de memoria
on the Blackwell chip
con
and
el
all the memory that's
chip de
connected to
Blackwell.
it. It's almost as if we shipped with every single chip
Es como
its
que con cada
own
chip
advanced tester
tienes
that
un
we
testador
test our chips
avanzado
with.
en cada chip.
This is the first time we're doing this.
Esta es la primera vez que
Super
hacemos
excited
esto.
about it.
Estoy
Secure
excitado por
AI.
ello. Superchip de ya. 208 billones de transistores.
Only this conference do they clap for RAS. The secure AI. Obviously, you've just spent hundreds of millions of dollars creating a
Habéis
very
gastado
important AI.
millones
And
de
the code,
dólares
the intelligence of
usando
that
IA
AI is
para
encoded in the
crear la
parameters.
IA.
You want to make sure that on the one hand, you don't lose it. On the
Quieres
other hand, it doesn't
asegurarlos
get contaminated.
Que no se
And
ven
so
contaminados
we
estos
now have
modelos
the
de IA.
ability to encrypt data,
Tiene la capacidad
of
de
course,
encriptar
at
datos
rest, but also in transit and
En
while it's
tránsito,
being computed.
mientras están siendo computados.
All encrypted.
Todo
And so
está
we now have
encriptado.
the ability to encrypt in transmission, and
Encriptación y
when we're computing
transmisión
it, it
encriptada
is in a trusted environment,
en
trusted
un ambiente de
engine
confianza.
environment. And the last thing is decompression.
Y lo último, la
Moving data in and
descompresión.
out of these nodes when the compute is so fast
Cuando la
becomes
computación está
really
más rápida,
essential.
es
And so
esencial.
we've put in a high line speed compression engine and effectively
línea alta
moves
de
data 20
velocidad
times
de
faster
descompresión.
in and out of these computers. These computers are
Estas
so
computadoras
powerful
son
and they're
tan
such a
potentes
large investment
que
that
es
the
toda una
last thing
tal
we want to do
inversión tan
is
grande.
have them be idle. And so all of these capabilities are intended to keep
Todas estas
Blackwell
capacidades
fed and as busy
lo
as
que intentan
possible.
es que mantener a Blackwell lo más ocupado
Overall,
posible.
compared to Hopper,
La mayor parte del tiempo.
it
Comparado
is
con Hopper,
2.5 times
dos veces más
the
y
FP8
medio más
performance for training per chip.
por chip.
It also has this new
petaflops.
format called FP6, so that even though the computation speed is the same,
La velocidad de
the
computación es la misma.
bandwidth that's amplified
El ancho de
because
banda
of
se ha
the memory,
incrementado,
the amount of
incrementado.
parameters you can store in the memory is
Los
now
parámetros que puedes
amplified.
meter en la memoria son
FP4
mayores.
effectively doubles the throughput. This is vitally important for inference.
Es muy
One of the
importante
things
para la
that,
inferencia de IA.
is becoming very clear is that whenever you use a computer
Cuando
with
usas una
AI on the
computadora
other side,
De IA.
when you're chatting with the chatbot,
Cuando estás
when you're
chateando con el
asking
chatbot,
it
le estás preguntando,
to review or make an image,
haz una imagen o un review de algo.
remember, in the back is a GPU
Por detrás
generating tokens.
hay un GPU generando tokens.
Some people call it inference,
Algunas
but
personas
it's
le llaman
more
inferencia.
appropriately generation.
Yo le llamaría generación.
The way that computing is done in the past
La manera de la
was
computación que
retrieval.
estaba haciéndose
You would
antes,
grab your phone, you would touch something, some signals go off, basically an email
Algunas
goes
señales
off to some storage somewhere.
se
There's
almacenan a un sitio.
pre-recorded content, somebody wrote a story or somebody made an image or somebody recorded a
Alguien hace
video.
un vídeo,
That
una imagen,
pre-recorded content is
contenido
then
pregrabado,
streamed back to the phone and
y luego lo llevas
recomposed in a
al
way
móvil, al teléfono,
based on a recommender system to
un
present
sistema
the
de
information
recomendador
to you.
que te presenta la
You know
información.
that in the future,
En el futuro,
the vast majority of that
la
content
mayor parte de
will
ese
not be
contenido
retrieved.
no
And the
tendrá que
reason
ser
for that is
recuperado.
because that was pre-recorded by somebody
Se ha
who doesn't understand the context,
grabado
which
por
is the
alguien que
reason
no
why we
entiende
have
el
to retrieve
contexto.
so much content. If you can be working with an AI
Si tú
that
quieres trabajar con una
understands the
IA,
context, who you are, for what reason you're fetching this information, and produces the information for you
produce
just the way
sí,
you like
es
it,
decir, que no es contenido
the amount
pregenerado,
of
sino generado en
energy
el
we
momento.
save the amount of networking bandwidth we save, the amount of wasted time we save, will
Ahorramos
be
tiempo,
tremendous.
ahorramos ancho de
The
banda.
future is generative,
El futuro
which
es
is the reason
generativo.
why we call it generative AI,
Por eso lo llamamos IA
which is the reason
generativa.
why this is a brand new industry.
Es una nueva
The way
industria.
we compute
La manera en la que
is
computamos
fundamentally different.
es más
We
distinta.
created a processor for the generative AI era.
Este es un procesador para
And
la
one of the most
era
important parts of it
generativa.
is content token generation. We
Y
call it
la
this
generación de
format
token es
is
importante.
FP4. Well, that's a lot of computation.
Mucha computación.
5x the token generation,
por
5x the
la
inference
generación de
capability of Hopper seems like
En
enough.
comparación con Hopper.
But why stop there?
¿Pero por qué no pararnos ahí? ¿Es suficiente? No,
The
no es
answer is it's
suficiente.
not enough. And
No
I'm
es
going to show you
suficiente.
why.
Os enseñaré
I'm
por
going to show
qué.
you why. And so we would like to have a bigger GPU,
Tenemos
even
un
bigger than
GPU
this one.
más grande.
And so we decided to scale it.
No puede
And
ser.
notice, but first, let me just tell you how we've
20.000
scaled.
teraflops.
Over the course
8 años.
of the last 8 years, we've
Vale,
increased
estamos aquí
computation
ahora,
by
arriba.
1,000
Pues
times. 8
4.
years, 1,000 times. Remember, back in the good old days of
En
Moore's
los buenos
Law,
días de la ley de Moore
it was 2x, well,
era
5x every,
por,
10x every 5 years.
ahora
That's
tenemos
easiest,
10x
easiest
cada
math. 10x every
5
5 years,
años.
100 times every 10 years.
100 años
100
cada
times
10
every 10
años.
years.
100
At
por
the-
cada 10. No,
in the
1000.
middle,
Computación
the
de,
heydays
de IA,
of
1000
the
por cada
PC
8
revolution.
años. Mira el escalado.
100 times every 10 years. In the last 8 years,
En los
we've
últimos
gone
8
1,000
años,
times. We have 2 more years
1000
to go.
veces por.
And so that puts it in perspective.
Eso nos pone en perspectiva, ¿no?
The rate at which we're advancing
El ratio en
computing
la
is
que
insane.
estamos
And it's
avanzando es
still not fast
increíble,
enough, so we
de
built
locos.
another chip.
Y pues hay otro chip aquí.
This chip
Este chip
is just an incredible chip. We call it the NVLink switch.
lo llamamos el NVLink
It's
Switch.
50 billion transistors. It's
50
almost the
billones de
size of Hopper
transistores
all
en
by
TSMC,
itself.
4 NP, lo
This
que quiera que
switch chip
signifique eso.
has 4 NVLinks in it, each 1.8 terabytes per second,
7,2 terabytes
And-
por segundo, full duplex ancho de
and
banda.
it has computation in it, as I mentioned. What is this chip for?
¿Para qué es esto?
If we were to build such a chip,
Si construimos esto es
we can
para
have every single GPU
que para
talk to every other
GPU hable
GPU
con
at
cada
full speed
GPU a
at the
completa
same
velocidad al
time.
mismo tiempo.
That's insane.
Esto es increíble.
It doesn't even make sense.
Ni siquiera tiene sentido.
But if you could do that,
Pero si
if you
puedes
can
hacer
find a
esto,
way to do that,
si
and
encuentras una
build
manera
a
de hacer esto,
system to do that,
Y creas un
that's
sistema con
cost
esto,
effective.
es
That's
relación
cost
coste-efectivo positiva.
How incredible would it be
Es
that we could
increíble
have
cómo
all these
resultará.
GPUs
Todos estos
connect
GPUs
over a coherent
conectándose
link
con un
so
enlace
that they
coherente
effectively are one giant GPU?
con un
Well,
gigante GPU.
one of the great inventions in order to make it cost effective is that this chip has to
chip
drive copper directly. The SerDes of this chip is just a phenomenal invention.
Es una
So
invención
that we
fenomenal.
can do direct drive to
Fenomenal.
copper. And as a result,
De cobre.
you can build a system that looks like this.
Pues crear un sistema que tiene esta pinta. 22 por. Vale, me imagino comparando con
Now this
Hopper.
system is kind of insane.
Solo un GPU, ¿vale?
This
Gran
is one
GPU.
DGX. This is what a DGX looks like now.
DGX.
Remember, just 6 years ago,
Solo hace 6 años, ¿recuerda?
it was pretty heavy, but I
Era
was
muy
able to
pesado
lift it.
hacer esto. Mira ahora.
I delivered the first DGX1 to
El
OpenAI.
primer DGX
and,
lo
and
mandé a
the
OpenAI.
researchers there, it's on, the pictures are on the internet. And,
Las fotos están en internet.
and we all autographed it.
Hicimos un autógrafo.
And if you come to my office, it's
Vienes a mi
autographed
oficina,
there. It's
lo
really
encontrarás.
beautiful. But you could lift it.
Pero puedes
This
levantarlo.
DGX, that DGX, by the way, was 170 teraflops.
170
If you're not familiar with the
Teraflops.
numbering system, that's 0.17 petaflops.
Pues
So
este
this
es de
is 720.
720 petaflops.
The first one I delivered to OpenAI was 0.17.
El primero
You
que
can round it up
envías
to 0.2,
era
won't make any difference.
0.7
But
que
back
envía a
then, it was
OpenAI.
like, wow,
Madre
30
mía, se
more
quedaron flipados.
teraflops. And so this is now
Teraflops. Pues estos son
720
petaflops.
petaflops almost
Ya me
an
dijo
exaflop for
GPT-4
training,
las nuevas
and the
escalas,
world's
las
first
nuevas
one
dimensiones
exaflops machine
de tamaño,
in
¿vale?
one rack.
Y de procesamiento, ¿vale? Que lo de petaflops está quedando muy... está pasándose de moda ya, por no hablar de, claro, de exaflops también, es que eso es exascala.
Just so you know, there are only a couple, 2, 3 exaflops machines on the planet as we speak.
Hay muy pocas
And so
computadoras
this is an exaflops AI
en la Tierra
system
de este estilo.
in one
Bueno,
single
están las
rack.
cuánticas.
Well, let's take a look at the back of it. So this is what makes
Cuánticas
it
es otra
possible.
historia.
That's the back. That's the back.
Esta es la
The
parte de atrás
DGX NVLink spine.
de la espina de
130
NVLink.
terabytes per second goes through the back of that chassis. That is more
Por
than
la
the
parte de
aggregate
atrás del
bandwidth
chasis.
of the internet.
Los cordones, ¿eh? Madre mía.
So we could basically send everything to everybody within a second.
Podemos enviar esto
And
cada
so we have
cada
5,000
segundo.
cables, 5,000 NVLink cables, in total 2
5.000
miles.
NVLink cables.
Now, this is the amazing thing. If we had to use optics, we would have had to use transceivers and retimers, and those
Tenemos que
transceivers
usar
and retimers
transceivers y
alone
retimers, no sé qué
would
es
have
eso.
cost 20,000 watts, 2
20.000
kilowatts of just transceivers
watts.
alone, just to drive the NVLink spine.
Solo para
As a result,
mover la spine, la
we did
espina
it
dorsal
completely
del
for free
NVLink.
over NVLink switch, and we were able to save the 20 kilowatts for computation. This entire rack is 120 kilowatts, so that 20 kilowatts makes a huge difference.
Me he perdido.
It's liquid cooled. What goes in is
Eso
25 degrees C,
se
about
refresca
room
de manera
temperature.
líquida.
What comes out is 45 degrees C, about your
45
jacuzzi.
grados, bueno, no está
So
mal.
room temperature goes in, jacuzzi comes out, 2 liters per second.
2 litros por segundo.
We could sell a peripheral.
Podemos vender un periférico. ¿Eh?
600,000 parts.
600.000
Somebody used to say,
partes.
you know, you guys make GPUs, and we do, but this is what a GPU looks
Nosotros
like to
hacemos
me.
GPUs, pero ahora mira
When
las
somebody
GPUs como
says
son.
GPU, I see this.
Cuando
2 years
dices
ago,
GPUs,
when I
yo veo
saw a
esto.
GPU, was the HGX. It was 70 pounds, 35,000 parts. Our GPUs now are 600,000 parts and
600.000
3,000
partes.
pounds. 3,000 pounds.
3.000
3,000 pounds, that's kind of like the
libras
weight of
esterlinas.
a
Pounds,
you know,
no, o sea, pero,
carbon fiber
¿qué te refieres?
Ferrari.
3.000 kilos.
I don't know if that's useful metric, but everybody's going, I feel it. I feel it. I get it.
Lo siento, lo pillo.
I get that.
Lo pillo.
Now that you mention that, I feel it.
Ahora que lo
I don't know
ahora
what's
dices,
3,000 pounds.
no sé cómo decir 3.000
Okay, so 3,000 pounds, ton and a half.
libras.
So it's not
Una
quite an
tonelada y
elephant.
media.
So this is what a DGX looks like.
Esto es
Now
lo que
let's
pasa
see
en
what it
DGX.
looks like in operation. Okay, let's imagine
Y mira,
how do we
cómo
put this to work
funcionaría.
and what does that mean? Well, if you were to train a GPT model,
Si tú tienes que entrenar un
1.8 trillion
modelo
parameter model,
del LM,
it took about 3 to 5 months
Entrenar
or
un modelo,
so
mira, 90 días,
with 25,000 amperes.
con 8.000
If
GPUs
we were to do it with
Hopper, ¿vale?
Hopper, it would probably take something like 8,000 GPUs, and it would consume 15 megawatts.
Consumiría
8,000 GPUs and 15 megawatts. It would take 90
megavatios.
days, about 3 months. And that would
¿Vale?
allow you to train
Mira qué rack
something
tienes ahí, qué
that
montón
is,
de
this
trastos.
groundbreaking AI model. And this is obviously not as expensive as anybody would think, but it's
No está
8,000
caro como
8,000
pensaríamos, pero
GPUs.
bueno,
It's
es
still a lot of money.
bastante caro. ¿eh?
And so 8,000 GPUs, 15 megawatts. If you were to use Blackwell to do this,
Si usas Blackwell para
it
esto,
would only take
para lo mismo,
2,000 GPUs.
usarías 2.000
2,000
GPUs y
same
4
90 days.
millones de
But this is the amazing
megavatios.
part. Only 4 megawatts of
Solo un
power.
cuarto de la
So
potencia
from
eléctrica.
15, yeah, that's right.
4 megavatios. Claro,
And
que aquí te
and
hay que
that's
bajar la
our goal.
calefacción.
Our goal is to
A ver,
continuously drive down the cost and the
que
energy. They're
aquí
directly
la
proportional to each other,
electricidad
cost and energy
va a haber apagones. Digo, claro,
associated
no
with the
extraña.
computing, so that we can continue to expand and scale up the computation that we have to do to train the next generation models.
Para
Well,
entrenar
this is training.
los modelos de la siguiente generación.
Inference or generation
Y la diferencia de
is
generación
vitally important going forward.
va a ir
Probably
adelante.
some half of the time that NVIDIA GPUs are in the cloud these days, it's being used for token generation.
La mayor parte
They're either doing Copilot this or
se usa para Copilot,
ChatGPT that,
generación
or
de modelos,
all these different models that are
dibujicos, ya
being
sabes.
used when you're interacting with it, or generating images, or generating videos, generating
Vídeos,
proteins, generating chemicals.
proteínas,
There's a
químicos,
bunch of
productos
generation
químicos.
going on. All of
Generación,
that
generación,
is
generación.
in the category of computing we call inference.
Todo esto va
But
en la
inference
categoría de
is extremely
computación llamada
hard
inferencia.
for large language models because these large language models have several properties. One, they're very
Estos
large.
LLM son
And so
muy
it doesn't
grandes.
fit on one GPU.
No encajan en un
This is,
GPU.
imagine Excel doesn't fit on one GPU.
Imagínate
You know?
Excel,
And imagine some application you're running on a
una
daily basis
aplicación
doesn't fit on one
que
computer.
no encaja en, una
Like a
sola
video game
en un
doesn't
solo
fit on one
ordenador.
computer.
Pues esto es así.
And most, in fact, do. And many
La mayor parte de las
times,
aplicaciones
in
sí,
the
pero
past,
esto no.
in hyperscale computing, many applications for
Necesitas
many
un
people
tocho de
fit on the
estos.
same computer. And now, all of a sudden, this one inference application where
Ahora
you're
de repente hay una
interacting with this
aplicación de inferencia.
chatbot, that chatbot requires a supercomputer in the back to
Chatbot
run it.
requiere una
And that's the
supercomputadora.
future. The future is
Este es el
generative
futuro.
with these chatbots, and these chatbots are trillions of tokens,
Estos chatbots tienen
trillions of
trillones de
parameters,
tokens.
and they have to generate tokens
Tienen que generarse tokens
at interactive rates. Now, what
a
does that mean?
tasas interactivas.
Oh, well,
Tasas.
3 tokens is about a word.
3 tokens es eso como una palabra.
You know, space, the final frontier.
Este no lee
these
el
are the
teleprompter como
adventures.
Biden,
That's like 80 tokens.
80 tokens.
Okay, I don't know if that's useful to you. And so, the art of communications is selecting good analogies.
El equipo de comunicación
This
está
is not
seleccionando
going well.
buenas analogías.
Everybody's, I don't know what he's talking about.
No sé de qué estaba hablando.
Never
ya.
seen Star Trek.
¿No habéis visto
And
Star Trek?
so here we are, we're trying to generate these tokens. When you're interacting with it, you're hoping that the tokens come back to you as quickly as possible and as
Esperáis que
quickly
esos
as you
tokens
can read.
vuelvan
And
a
so
ti
the
lo más
ability
rápido
for
posible.
generation tokens
Pues
is really
eso, preguntas y
important. You have to
respuestas.
parallelize the work of this model across many, many GPUs
Necesitas
so that you
hacer
could
que
achieve
funcione
several
a través
things.
de
One,
muchos
on the
GPUs
one
este
hand, you would
modelo.
like throughput because that throughput reduces the cost, the overall cost per token of generating. So
Claro,
your
o sea, que la clave es que como es una
throughput
red,
dictates
tienes que
the cost
actuar en
of,
paralelo. Estos GPUs tienen que estar
delivering
bien
the service.
comunicados. Esa
On
es
the
la
other
clave.
hand, you have another interactive rate, which is another tokens per second, where it's about per user, and that has everything to do with quality of service. And so these two
Tiene
things
todo que ver con la calidad del servicio.
compete against each other. And we have to find a way to distribute
GPUs
work
compiten
across
entre
all
ellos.
of these different GPUs and
Y entonces
parallelize
estas
it in a
GPUs
way that allows us to achieve both. And it turns out the search space is enormous.
El espacio de búsqueda es enorme.
You know, I told you there's going to be math involved. And everybody's going, oh dear.
Tokens por segundo, throughput.
I heard some gasps just now when I put up that slide. You know, so this right here, the y-axis is tokens per second, data center throughput. The x-axis is tokens per second, interactivity of the person. And notice the upper right is the best. You want interactivity to be very high,
Arriba a la derecha,
number of
a la
tokens per
derecha es lo
second per
mejor.
user. You want the tokens per second per data center to be very high. The
Mucha,
upper right is
50
terrific.
más,
However,
mucha
it's very
interactividad
hard
por
to do that.
usuario
And
en
in
tokens
order
por
for us to
segundo
search
y
for the best
muy alto el
answer,
throughput por GPU.
Across every single one of those intersections, XY coordinates, okay, so just look at every
Esas
single
coordenadas que
XY
habéis visto, los puntos
coordinate,
azules,
all those blue dots came from some repartitioning of the software.
Viene de alguna
Some
repartición del software.
optimizing solution has to go and figure out
Alguna solución
whether
tiene
to
que venir
use tensor parallel,
para usar paralelos,
expert parallel,
tensor
pipeline
parallels,
parallel, or data parallel,
data
and
paralelos,
distribute
y distribuirlos
this enormous model
entre estos
across all
modelos,
these different GPUs
enorme
and
modelo
sustain
en varios
performance that
GPUs
you need.
y sostenerlo en el tiempo.
This exploration space would be
Este espacio de
impossible
exploración
if
sería
not for
imposible
the programmability of NVIDIA's GPUs.
si la
And so we could,
programabilidad de los
because of
GPUs de
CUDA,
NVIDIA.
because we have such a rich ecosystem, we could explore this
Porque
universe
en
and
este
find
ecosistema podemos explorar
that
este
green
universo.
roof line. It turns out that green roof line, notice, you got TP2, EP8, DP4. It means
es que se me escapa ya.
two tensor parallel,
¿De qué
tensor
está
parallel
hablando
across
ya?
2 GPUs, expert parallels across 8, data parallel across 4.
Tensor
Notice on
parallel,
the other
pipeline
end, you got tensor
parallel,
parallel
expert
across
parallel,
4,
data
and
parallel.
expert
¿Qué coño
parallel
es eso?
across
No tengo ni
16.
puñetera idea.
The configuration, the distribution
La
of that
configuración,
software
la
is a
distribución de ese.
different runtime
Tiene un
that would
diferente
produce
runtime, periodo de carga,
these different results.
de
And you have to go
ejecución.
discover that roof line. Well, that's just one model.
Esto es un
And
modelo.
this is just one configuration of a computer.
Es una
Imagine
configuración de un
all of the
computador.
models being created around the world
Todos los modelos que
and all
están
the
creados en el mundo
different configurations of systems that are going to be available.
tienen distintas configuraciones que van a ser están
So now
disponibles. Así que
that you
ahora,
understand the basics,
si
let's
entendéis
take
lo
a
básico,
look at inference
vamos a ver la
of
diferencia
Blackwell compared to
de una comparativa de la diferencia de
Hopper.
Blackwell.
And this is the extraordinary thing.
Y esto es una cosa
In one
extraordinaria.
generation, because we created
En una generación
a
porque
system
creamos
that's
un
designed
sistema
for trillion
que ha sido diseñado
parameter
para
generative AI,
trillón de
the
parámetros de
inference
inteligencia
capability of
generativa.
Blackwell is off the charts.
Y lo de Blackwell es que está fuera de la escala.
And in fact, it is some 30 times Hopper.
Es 30 veces Hopper. El throughput por GPU, ya lo veis donde está Hopper, que es la cosa rosa.
For
esa.
large language models like ChatGPT and others like it, the blue line is Hopper. I gave you, imagine
cosa
we
roja-
didn't
no, la
change
cosa
the
azul.
architecture of Hopper.
Eso
We
es
just
Hopper.
made it a bigger chip. We just used the latest, greatest 10 terabytes per second. We connected the two chips together. We got this giant
Terabytes per
208 billion
segundo.
parameter chip. How would we have performed if nothing else changed? And it
¿Cómo
turns
podríamos
out quite wonderfully.
rendir si nada hubiese cambiado?
Quite wonderfully, and that's the purple line, but not as great as it could be.
No es
And
tan
that's
grande
where
como podría
the
ser.
FP4 Tensor Core, the new transformer engine, and very importantly, the NVLink switch. And
El
the reason
NVLink
for that
switch
is
es
because
clave.
all these GPUs have to share the results,
Porque
partial
tienen que todos los
products.
GPUs que compartir
Whenever
el
they
mismo
do
resultado.
all gather, whenever they communicate with each other,
Todos se comunican entre ellos.
that NVLink switch
Y ese switch
is
de NVLink
communicating almost 10 times
Está
faster
comunicando 20 veces más
than what we
rápido
could do in the past using the fastest networks.
de lo que podíamos hacer en el pasado
Okay,
usando
so-
esas redes.
Blackwell is going to
Así que
be
Blackwell
just an amazing
Va a ser
system
un
for
sistema
generative
increíble
AI.
para la IA
And in the
generativa. En el futuro,
data centers are going to be
Los centros de
thought of,
datos,
as I mentioned earlier, as an AI
como he
factory.
mencionado antes, serán fábricas
An
de
AI
IA.
factory's goal in life is to generate revenues.
Van a
Generate,
generar
in this case,
beneficios
intelligence
de inteligencia
in this facility,
en estas fábricas.
not generating electricity as
No
in
generando
AC generators,
electricidad.
but of the last industrial revolution and this industrial
Esta,
revolution, the
esta
generation of
revolución industrial
intelligence.
va a
And
generar
so this
inteligencia.
ability is super
No
important.
electricidad, sino
The
inteligencia. No
excitement
productos, sino
of
inteligencia.
Blackwell is really off the charts. When we first, this is a year and a half ago, 2 years ago.
un
I
año
guess
y
2
medio,
years
2
ago, when
años,
we
no
first
más.
started to go to
Hace
market with
siglos, ¿no?
Hopper. We had the benefit of
Mi
two,
Hopper me parecía que estaba en la
two
vanguardia. Bueno, pues
CSPs,
Hopper ya no es nada.
joined
Pues
us in
vale,
the
pues
launch.
estupendo.
And we were, delighted. And so we had 2 customers. We have more now.
Teníamos 2 clientes, ahora tenemos más. ¿Cuándo? No sé cuántos más, ¿no? Fujitsu, Gigabyte, no sé qué, OpenAI, tal cual. No, de nuevo,
Unbelievable
todos se apuntan al
excitement for
carro.
Blackwell. Unbelievable excitement.
Se
And
apuntan
there's a
al
whole
carro
bunch
de
of different
Blackwell.
configurations. Of course, I
Tesla,
showed you
Together
the
AI, X,
configurations that slide into the Hopper
Microsoft Azure,
form factor, so
Google
that's
Cloud,
easy to upgrade.
AWS,
I
Oracle,
showed you examples that are liquid
Character
cooled,
AI,
that are the extreme
Cohere.
versions of it. One entire rack that's connected by NVLink 72.
Un entero
We're
rack
gonna-
está conectado por el NVLink,
Blackwell
el NVLink
is going to
este.
be ramping to the world's AI companies, of which there are so many now, doing amazing
compañías de
work
IA
in
que
different
hay tantas
modalities.
ahora.
The CSPs, every CSP,
Cada CSP
is geared up. All the OEMs and
equipado.
ODMs, regional clouds, sovereign
nubes
AIs,
regionales,
and
IAs
telcos
soberanas,
all over the world are signing up to launch with
en todas
Blackwell.
partes del mundo.
This Blackwell would be the most successful product launch in our
Blackwell
history.
será el producto más
And so I can't
exitoso
wait
nuestro
to
en toda la
see that.
historia.
I want to thank some partners that
Quiero
are
agradecer a
joining
algunos
us in
compañeros
this.
aquí,
AWS is gearing
colaboradores.
up for Blackwell. They're
AWS,
going to build the first GPU with secure
Construirá
AI.
el
They're
primer
building out a
GPU.
222 exaflops system.
222
Just now when we animated just now
exaflops.
the digital twin, if you saw the all of those clusters are coming down. By the way, that is not just art. That is a digital twin of what we're building.
Un
That's how
doble
big it's
digital de lo
going
que
to
estamos
be.
construyendo.
Besides infrastructure, we're doing a lot of things together with AWS. We're CUDA accelerating SageMaker AI. We're CUDA accelerating Bedrock AI. Amazon Robotics is working with us using NVIDIA Omniverse and Isaac Sim. AWS Health has NVIDIA Health integrated into it. So AWS has really leaned into accelerated computing. Google is gearing up for Blackwell. GCP already has A100s, H100s, T4s, L4s, a whole fleet of NVIDIA CUDA GPUs. They recently announced the Gemma model that runs across all of it. We're working to optimize and accelerate every aspect of GCP. We're accelerating DataProc, which for data processing, the data processing engine, JAX, XLA, Vertex AI, and Mujoko for robotics. So we're working with Google and GCP across a whole bunch of initiatives. Oracle is gearing up for Blackwell. Oracle is a great partner of ours for NVIDIA DGX Cloud. And we're also working together to accelerate something that's really important to a lot of companies, Oracle database. Microsoft is accelerating, and Microsoft is gearing up for Blackwell. Microsoft and NVIDIA has a wide-ranging partnership. We're accelerating, CUDA accelerating all kinds of services. When you chat, obviously, AI services that are in Microsoft Azure, it's very, very likely NVIDIA is in the back doing the inference and the token generation. They built the largest NVIDIA InfiniBand supercomputer, basically a digital twin of ours, or a physical twin of ours. We're bringing the NVIDIA ecosystem to Azure. NVIDIA DGX Cloud to Azure. NVIDIA Omniverse is now hosted in Azure. NVIDIA Healthcare is in Azure. And all of it is deeply integrated and deeply connected with Microsoft Fabric. The whole industry is gearing up for Blackwell. This is what I'm about to show you. Most of the scenes that you've seen so far of Blackwell are the full fidelity design of Blackwell. Everything in our company has a digital twin. And in fact, this digital twin idea is really spreading, and it helps companies build very complicated things perfectly the first time. And what could be more exciting than creating a digital twin to build a computer that was built in a digital twin? And so let me show you what Wistron's doing.
To meet the demand for NVIDIA accelerated computing, Wistron, one of our leading manufacturing partners, is building digital twins of NVIDIA DGX and HGX factories using custom software developed with Omniverse SDKs and APIs. For their newest factory, Wistron started with a digital twin to virtually integrate their multi-CAD and process simulation data into a unified view. Testing and optimizing layouts in this physically accurate digital environment increased worker efficiency by 51%. During construction, the Omniverse digital twin was used to verify that the physical build matched the digital plans. Identifying any discrepancies early has helped avoid costly change orders, and the results have been impressive. Using a digital twin helped bring Wistron's factory online in half the time, just 2.5 months instead of 5. In operation, the Omniverse digital twin helps Wistron rapidly test new layouts to accommodate new processes or improve operations in the existing space, and monitor real-time operations using live IoT data from every machine on the production line, which ultimately enabled Wistron to reduce end-to-end cycle times by 50% and defect rates by 40%. With NVIDIA AI and Omniverse, NVIDIA's global ecosystem of partners are building a new era of accelerated AI-enabled digitalization.
NVIDIA están creando una nueva era en la revolución industrial de la IA. Wistron, primer envío.
That's how we are.
Fábrica N2.
That's the way it's going to be in the future. We're going to manufacture everything digitally first, and then we'll manufacture it physically. People ask me, how did it start? What got you guys so excited? What was it that you saw that caused you to put it all in on this incredible idea?
Esta increíble idea.
It's this.
Es esto.
Hang on a second.
Espera un momento. AlexNet, 2012.
Guys, that was going to be such a moment.
Oh, esto será un momentazo.
That's what happens when you don't rehearse. Sí. as you know,
Esto,
was
como
first
sabéis,
contact.
fue el primer
2012,
contacto.
AlexNet.
AlexNet,
You put a
2012.
cat into this computer,
Pues un
and it
gato en
comes
esta
out and it says,
computadora, una gráfica
cat.
cutrona como la que tengo yo, quizás.
And we said, oh my God,
Y dijimos,
this is going to
ostras,
change everything.
una foto de un gato y dice, esto es un
You
gato.
take
Esto
1
va a
million
cambiar todo.
numbers, you take 1 million numbers across
Cogemos
3
un millón de
channels
números,
RGB. These numbers
imagen de
make no sense to
RGB.
anybody. You put it into this software,
Lo pones en esta
and it
tarjeta gráfica,
it dimensionally reduces
compresionas y lo
it
reduces
reduces it
dimensionalmente
from a million dimensions,
a un millón de
it turns
dimensiones
it into 3 letters,
en 3
one
capas,
vector, one
un
number.
vector.
And it's
Y
generalized.
sale ahí, gato,
You could have the cat be different cats.
milagro.
And you could have it be the front of the cat and the back of the cat. And you look at this thing, you say, unbelievable. You mean
Increíble.
any cats? Yeah, any cat.
Cualquier gato.
And it was able to recognize all these
Fue
cats.
capaz de reconocer
And we
todos los
realized
gatos
how it did
distintos.
it.
Y todos eran gatos.
Systematically, structurally, it's scalable.
Es escalable. Y hasta
How
hoy.
big can you make it? Well, how big do you want to make it?
¿Cómo de
And
grande
so
lo
we
quieres hacer?
imagined that this is a completely new way of writing
¿Quién
software.
imaginaría que fuese un nuevo
And
tipo de
now today,
software?
as you know, you could have,
Y hoy en
you
día, pues,
type in the word
Pues la palabra
CAT,
C,
and what comes out is a cat.
C-A-T,
It went the other
y te sale
way.
gato. Y te apareció una imagen
Am
de
I
un gato.
right? Unbelievable.
Increíble.
How is it
¿Cómo
possible?
es posible?
That's right. How is it possible you
correcto.
took 3 letters
Has puesto 3 letras
and you
y te sale una
generated
imagen de
a
foto
million
de un
pixels from it,
gato.
and it made sense?
No tiene sentido.
Well, that's the miracle.
Bueno, este es el
And here
milagro.
we are,
Y aquí estamos.
just literally 10 years later,
Literalmente
10 years
10 años
later,
después.
where we recognize text,
12
we
años.
recognize
Reconocemos
images, we
texto,
recognize
vídeo,
videos
imágenes
and
3D,
sounds and images. Not
animación,
only
manipulación,
do we
proteínas,
recognize them,
discurso,
we understand
sonido.
their meaning. We
Entendiendo
understand the
el
meaning of the text.
significado.
That's the reason why I can chat with you. It
Puedo
can
hablar
summarize
contigo.
for you. It
Ondas
understands the
mentales,
text.
cuidado a la izquierda,
It
míralo.
understood, not just recognizes the English, it understood the
No
English.
reconoce el inglés,
It
sino
doesn't
cualquier
just
idioma.
recognize the pixels, it understood the pixels. And
Entiende los
you can
píxeles.
even condition it between 2 modalities. You can have language condition image and
Idioma
generate all
condicionando
kinds of
el,
interesting things.
el,
Well,
el
if you can
vídeo,
understand
vídeo
these
a
things,
imagen,
what else
imagen
can
a
you
sonido,
understand
sonido a
that you've
texto, texto a
digitized?
sonido, sonido a vídeo, en
The
fin.
reason why we started with text and images is because we digitized those. But what else have we digitized? Well,
¿Qué más
turns out
hemos
we digitized a lot of
digitalizado? Pues
things.
todo. Ahora está
Proteins
todo en la
and
red.
genes and
Genes,
brainwaves.
ondas mentales.
Anything you can digitize,
Todo lo que
so long
puedas
as there's
digitalizar, o
structure,
sea,
we
todo
can
en este
probably
mundo,
learn some
todo.
patterns from it. And if we can learn the patterns from it, we can
Puedes aprender
understand
los
its meaning.
patrones.
If we can understand its meaning,
Y puedes entender su
we might be able
significado.
to generate it as well. And so therefore, the generative AI revolution is
Así,
here.
porque eso,
Well,
la
what
IA
else
generativa ha
can we generate?
revolucionado
What
el
else can we
mundo.
learn? Well,
¿Qué
one
más
of the
puedes
things that we
aprender?
would love to learn,
¿Qué no le gustaría
is
aprender?
we would love to learn
Nos gustaría
climate.
aprender
We would love to learn extreme weather. We would
tiempos
love to learn
extremos.
how we can predict
¿Cómo podemos predecir
future weather
el futuro, el
at
tiempo
regional
futuro
scales at sufficiently high
con
resolution
suficiente resolución?
such that we can keep people out of harm's way
De esta
before
manera
harm
podemos
comes.
alejar a la gente del
Extreme
peligro.
weather cost the world $150 billion.
El tiempo extremo
Surely more
costa
than
mucho a
that,
la
it's
humanidad.
not evenly distributed. $150 billion is concentrated in some parts of the world. And of
Hay
course, to some
muchos
people of
recursos
the world.
distribuidos
We
en muy
need to
pocas
adapt,
partes del
and
mundo.
we need to know
Necesitamos
what's coming.
adaptarnos
And so we're creating Earth 2, a digital
y
twin of the Earth
tenemos que
for
adaptar a la
predicting
Tierra
weather.
también.
And we've
Hemos
made
creado
an
un doble digital de
extraordinary
la Tierra.
invention called CoreDiv, the ability to use generative AI
La posibilidad
to
de usar
predict
la IA
weather
generativa
at extremely high resolution. Let's take
a
a look.
una resolución extremadamente alta.
As the Earth's climate changes, AI-powered weather
Mientras
forecasting
el clima
is allowing
cambia,
us to more accurately predict and
la IA
track
permite
severe storms,
predecir
like
más
Super Typhoon
precisamente
Chanthu,
el
which
cambios
caused
climáticos,
widespread damage in
cambios del
Taiwan
tiempo.
and the surrounding region in 2021. Current AI forecast models can accurately predict the track of
Resolución de
storms,
25 kilómetros,
but they are
predicción de
limited to
ella.
25-kilometer resolution, which can miss important details.
Puedes
NVIDIA's
perder algunos
CoreDiv
detalles,
is a
pero Nvidia
revolutionary
consigue una
new
resolución
generative
de 2
AI model
kilómetros.
trained on
CoreDiv.
high-resolution, radar-assimilated WRF weather forecasts and ERA 5 reanalysis data. Using CoreDiv, Extreme events like Chanthu can be super resolved from 25 km to 2 km resolution, with 1,000 times the speed and 3,000 times the energy efficiency of conventional weather models. By combining the speed and accuracy of NVIDIA's weather forecasting model ForecastNet and generative AI models like Cordiff, we can explore hundreds or even thousands of kilometer-scale regional weather forecasts to provide a clear picture of the best, worst, and most likely impacts of a storm. This wealth of information can help minimize loss of life and property damage. Today, Cordiff is optimized for Taiwan, but soon, generative supersampling will be available as part of the NVIDIA Earth 2 inference service for many regions across the globe.
The Weather Company.
The Weather Company is the trusted source of global weather prediction. We are working together to accelerate their weather simulation. First principled base of simulation. However, they're also going to integrate Earth 2 Cordiff so that they can help businesses and countries do regional, high-resolution weather prediction. So if you have some weather prediction you'd like to know, like to do, reach out to the Weather Company. Really exciting work. NVIDIA Healthcare. Something we started 15 years ago. We're super excited about this. This is an area where we're very proud. Whether it's medical imaging or gene sequencing or computational chemistry, it is very likely that NVIDIA is the computation behind it. We've done so much work in this area. Today we're announcing that we're going to do something really cool. Imagine all of these AI models that are being used to generate images and audio, but instead of images and audio, because it understood images and audio, all the digitization that we've done for genes and proteins and amino acids, that digitization capability is now passed through machine learning so that we understand the language of life. The ability to understand the language of life, of course, we saw the first evidence of it with AlphaFold. This is really quite an extraordinary thing. After decades of painstaking work, the world had only digitized and reconstructed using cryo-electron microscopy or X-ray crystallography. These different techniques painstakingly reconstructed the protein. 200,000 of them in just what is it, less than a year or so? AlphaFold has reconstructed 200 million proteins. Basically every protein, every living thing that's ever been sequenced. This is completely revolutionary. Those models are incredibly hard to use, incredibly hard for people to build, and so what we're going to do is we're going to build them. We're going to build them for the researchers around the world. And it won't be the only one. There'll be many other models that we create. So let me show you what we're going to do with it.
Os voy a enseñar lo que haremos con ellos.
Virtual screening for new medicines is a computationally intractable problem. Existing techniques can only scan billions of compounds and require days on thousands of standard compute nodes to identify new drug candidates. NVIDIA BioNeMo NIMs enable a new generative screening paradigm, using NIMs for protein structure prediction with AlphaFold, molecule generation with MolMIM, and docking with DiffDock. We can now generate and screen candidate molecules in a matter of minutes. MolMIM can connect to custom applications to steer the generative process, iteratively optimizing for desired properties. These applications can be defined with BioNeMo microservices or built from scratch. Here, a physics-based simulation optimizes for a molecule's ability to bind to a target protein, while optimizing for other favorable molecular properties in parallel. MolMIM generates high-quality drug-like molecules that bind to the target and are synthesizable, translating to a higher probability of developing successful medicines faster. BioNeMo is enabling a new paradigm in drug discovery with NIMs, providing on-demand microservices that can be combined to build powerful drug discovery workflows like de novo protein design or guided molecule generation for virtual screening. BioNeMo NIMs are helping researchers and developers reinvent computational drug design.
Desarrolladores y a mejorar, bueno, pues lo de la salud.
NVIDIA MolMIM MolMem, Core
Tiene mucho que
Diff.
trabajar
There's
en
a
esto.
whole bunch of other models.
Hay muchos modelos.
Computer vision models,
Modelos de visión de
robotics
computadora.
models, and even, of course, some really, really terrific open source
Algunos modelos
language models.
de código
These
abierto.
models
Estos
are
modelos
groundbreaking. However, it's hard for
revolucionarios.
companies to use. How would you use it?
¿Cómo
How
los
would you bring it
usaríamos?
into your company and integrate it into your workflow? How would you
Integrándolos
package
en
it up and
el
run it?
diagrama de
Remember,
flujo.
earlier I just said
Recuerda, antes dije
that inference is an extraordinary
que la
computation problem.
inferencia es un modelo
How would you do the optimization
de
for each and every one of these models
A ver.
and put together the computing stack necessary to run
Para
that
poder,
supercomputer
en
so that
marcha
you
el
can run these
supercomputador
models
necesario para
in your
esto?
company? And so we have a great idea.
Tenemos una gran
We're going to
idea.
invent a new way,
Hemos inventado una nueva manera
for you to
para que vosotros
receive and operate
podáis
software.
recibir y operar software.
This software
Este software
comes basically
viene
in a
básicamente
digital box. We call
en
it a
una caja
container.
digital.
And we call it the NVIDIA Inference Microservice.
El microservicio
NIM.
de
And
diferencia
I'll
de
explain to
NVIDIA.
you what it is.
Os
A
diré
NIM.
qué es.
It's a pre-trained model.
Es un
So
modelo
it's pretty clever.
preentrenado de IA.
And it is packaged
Empaquetado y
and
optimizado
optimized
para
to run
correr
across
a
NVIDIA's
través de
install base,
base
which
instalada
is very, very large.
de
What's
CUDA,
inside it
perdón.
is incredible.
Cientos
You
de
have all
millones de
these
GPUs
pre-trained
CUDA
state-of-the-art
instaladas.
open source models. They could be open source. They could be from one of our partners.
Puede ser
They
de
could be
código
created
abierto.
by us, like NVIDIA Moment.
A través
It
de
is packaged
Kubernetes.
up with all of its dependencies. So CUDA, the right version. cuDNN, the right version. TensorRT, LLM, distributing across the multiple GPUs. Trident Inference Server, all completely packaged together. It's
Todo
optimized
empaquetado junto.
depending on whether you have a single GPU, multi-GPU, or
Ya
multi-node
sea que
GPUs.
tengas una
It's
GPU,
optimized for
muchas
that.
GPUs,
And it's connected up with APIs that are simple to use.
es muy
Now
simple de
this,
usar.
think about what an AI API is.
Piensa lo que es una
An
AI,
AI is an interface
una
that
API
you just
de
talk
una
to.
IA.
And so this is a piece of software in the future
Esto es un
that
software
has
que en
a
el futuro
really simple API, and that API is
va a
called
ser como
Human.
una API
And
muy simple.
these packages, incredible bodies of software,
Estos
will be
cuerpos de software
optimized and packaged,
increíbles
and we'll put it on a website,
lo pondrán en una página web,
and you can download it, you
puedes
can take it with
descargarlo,
you,
te lo
you
llevas,
can run it in any
lo
cloud,
podrás ejecutar en
you can
cualquier
run it in
nube,
your own data center, you can
con
run in
tu
workstations if it
en tu
fit,
lugar de trabajo.
and all you have to do is come to ai.nvidia.com.
Lo que
We
necesitas
call
es
it
ir a
NVIDIA
nvidia.com.
Inference Microservice, but inside the company we all call it NIMS. Okay?
Veremos a ver. Para profesionales, imagino.
Just imagine, you know,
Imaginaos.
someday there's going to be one of these
¿Alguna vez
chatbots,
va a haber
and
alguno
these
de estos
chatbots is going to
chatbots
just be in a NIM.
que estén
And
en NIM?
you'll assemble a whole bunch of chatbots. And that's the way software is going to be built someday. How do we build software in the future?
¿Cómo construimos
It
software
is
en el
unlikely
futuro?
that you'll write it from scratch or write a whole bunch of Python
Ya
code or
sea desde el
anything like
principio con
that.
código
It is
Python,
very likely that you assemble a
probable
team of AIs.
que creas un
There's
grupo de
probably
ellas
going to be a super
Enjambre.
AI that you use that takes the mission that you give it
con la misión
and
que tú
breaks
le
it
des
down into an execution plan.
y con un plan de
Some of that
ejecución.
execution plan could be handed off to another NIM.
Ya
That
puede ser
NIM would
ir
maybe
a otro NIM,
understand SAP.
entender tan
The
pronto como
language
sea
of SAP
posible,
is ABAP. It might understand ServiceNow. And it go retrieve some information from their platforms.
ir a recuperar cierta
It might
información de
then
las
hand that
plataformas,
result to another NIM who goes
Ir a otro
off and
NIM,
does some calculation on it. Maybe
hacer
it's an
cálculos ahí.
optimization software, a combinatorial optimization algorithm. Maybe it's
Algoritmo de
some
optimización.
basic calculator. Maybe it's pandas to do some numerical analysis on it.
Hacer algún
And then it
análisis
comes back
numérico.
with its answer. And it gets combined with everybody else's.
Se
And
combina.
because it's been presented with this is what the right answer should look like,
Porque
it knows
se
what,
presenta como que esta es la respuesta
right
correcta que
answers
debería
to
hacer.
produce, and it presents it to you.
y te lo
We can
presenta
get a
a ti.
report every single day at top of the hour that has something to do with a bill plan or some forecast or some
predicción,
customer alert
algún
or some
plan
bugs
de un
database or
presupuesto.
whatever it happens to be. And we could assemble it using all these NIMs.
Podemos
And because these
ensamblarlo
NIMs
usando
have
estos
been
NIMs.
packaged up and ready to work on your systems, so long as you have
Listos
NVIDIA
para trabajar en
GPUs in
tus
your data
sistemas.
center or in the cloud, this
Pasarlo a la nube.
NIMs will work together as a team
Pueden
and do
trabajar juntos
amazing
como un
things.
equipo.
And so we decided,
Nosotros
this
decidimos,
is such a great idea, we're going to go do that.
vamos a hacer
And so
esto.
NVIDIA has NIMs running all over the company. We have chatbots being created all over the place, and one of the most important chatbots, of course,
NVIDIA,
is a chip designer chatbot. You might not be surprised. We care a lot about building chips. And so we want to build chatbots, AI co-pilots, that are co-designers with our engineers. And so this is the way we did it. So we got ourselves a Llama 2. This is a 70B, packaged up in an M. And we asked it, what is a CTL?
Escribe un ejemplo con una prueba de
CTL is an
CTL.
internal
Lógica
program,
de
and it has an internal proprietary language. But it thought the CTL was a combinatorial timing logic, and so it describes conventional knowledge of CTL. But that's not very useful to us. And so we gave it a whole bunch of new examples. This is no different than onboarding an employee. We say, thanks for that answer. It's completely wrong. And then we present to them, this is what a CTL is. Okay, and so this is what a CTL is at NVIDIA. And the CTL, as you can see, CTL stands for Compute Trace Library, which makes sense. We're tracing compute cycles all the time, and it wrote the program.
Y te hace un programa. ¿No es que increíble?
And so the productivity of our chip designers can go up. This is what you can do with a NIM. First thing you can do with it is customize it. We have a service called Nemo microservice that helps you curate the data, preparing the data so that you could teach this, onboard this AI. You fine-tune them, and then you guardrail it. You can even evaluate the answer, evaluate its performance against other examples. And so that's called the Nemo microservice. Now, the thing that's emerging here is this. There are three elements, three pillars of what we're doing. The first pillar is, of course, inventing the technology for AI models and running AI models and packaging it up. The second is to create tools to help you modify it. First is having the AI technology. Second is to help you modify it. And third is infrastructure for you to fine-tune it, and if you like, deploy it. You could deploy it on our infrastructure called DGX Cloud, or you can deploy it on-prem. You can deploy it anywhere you like. Once you develop it, it's yours to take anywhere. And so we are effectively an AI foundry. We will do for you and the industry on AI what TSMC does for us building chips. And so we go to it with go to TSMC with our big ideas. They manufacture it, and we take it with us. And so exactly the same thing here. AI Foundry, and the three pillars are the NIMs, Nemo microservice, and DGX Cloud. The other thing that you could teach the NIM to do is to understand your proprietary information. Remember, inside our company, the vast majority of our data is not in the cloud. It's inside our company. It's been sitting there, being used all the time, and gosh, it's basically NVIDIA's intelligence. We would like to take that data, learn its meaning, like we learned the meaning of almost anything else that we just talked about. Learn its meaning, and then re-index that knowledge into a new type of database called a vector database. And so you essentially take structured data or unstructured data, you learn its meaning, you encode its meaning, so now this becomes an AI database, and that AI database, in the future, once you create it, you can talk to it. And so let me give you an example of what you could do. So suppose you've got a whole bunch of multi-modality data, and one good example of that is PDF. So you take the PDF, you take all of your PDFs, all your favorite, the stuff that is proprietary to you, critical to your company, you can encode it, just as we encoded pixels of a cat, and it becomes the word cat. We can encode all of your PDF, and it turns into vectors that are now stored inside your vector database. It becomes the proprietary information of your company. And once you have that proprietary information, you can check it. It's a smart database. And so you just chat with data. And how much more enjoyable is that? For our software team,
para nuestro equipo de software,
just chat with the bugs database.
hacer
how many
un
bugs
chat
was
con,
there last
con
night?
una base de
Are we
datos.
making any progress? And
Hoy
then
estamos
after
haciendo
you're
un
done
avance.
talking to this bugs
¿Me
database, you
recuperas
need
esto? No sé
therapy.
qué.
And so we have another chatbot for you.
Tenemos otro chatbot para ti. Para vosotros.
You can do it.
Podéis hacerlo.
Okay, so we call this Nemo Retriever, and the reason for that is because ultimately its job is to go retrieve information as quickly as possible. And you just talk to it. Hey, retrieve this information, and it goes, oh, it brings it back to you. Do you mean this? You go, yeah, perfect. Okay? And so we call it the Nemo Retriever. Well, the Nemo service helps you create all these things, and we have all these different NIMs. We even have NIMs of digital humans.
I'm Rachel.
Ni siquiera tenemos NIMs de humanos digitales, ¿cómo que no?
Okay, so it's a really short clip, but
muy corto.
There were so many videos to show you, I guess so many other demos to show you, and so I had to cut this one short. But this is Diana. She is a digital human NIM.
Es un digital humano.
You just talked to her, and she's connected, in this case, to Hippocratic AI's large language model for healthcare. And it's truly amazing.
Es un LLM para salud.
She is just super smart about healthcare things.
Muy inteligente de cosas de la salud.
And so after you're done, after my Dwight, my VP of software engineering, talks to the chatbot for Bugs database, and you come over here and talk to Diane.
Con Diana.
And so Diane is completely animated with AI.
Está animada con IA.
Human.
Y parece una humana.
There's so many companies that would like to build. They're sitting on gold mines. The enterprise IT industry is sitting on a gold mine. It's a gold mine because they have so much understanding of the way work is done. They have all these amazing tools that have been created over the years, and they're sitting on a lot of data. If they could take that gold mine and turn them into copilots, these copilots could help us do things. And so just about every IT franchise, IT platform in the world that has valuable tools that people use is sitting on a gold mine for copilots. And they would like to build their own copilots and their own chatbots. And so we're announcing that NVIDIA AI Foundry is working with some of the world's great companies. SAP generates 87% of the world's global commerce. Basically, the world runs on SAP. We run on SAP. NVIDIA and SAP are building SAP Joule copilots using NVIDIA Nemo and DGX Cloud. ServiceNow, they run 85% of the world's Fortune 500 companies run their people and customer service operations on ServiceNow. And they're using NVIDIA AI Foundry to build ServiceNow Assist virtual assistants. Cohesity backs up the world's data. They're sitting on a gold mine of data. Hundreds of exabytes of data, over 10,000 companies. NVIDIA AI Foundry is working with them, helping them build their Gaia generative AI agent. Snowflake is a company that stores the world's digital warehouse in the cloud and serves over 3 billion queries a day for 10,000 enterprise customers. Snowflake is working with NVIDIA AI Foundry to build copilots with NVIDIA Nemo and NIMS. NetApp, nearly half of the files in the world are stored on-prem on NetApp. NVIDIA AI Foundry is helping them build chatbots and copilots like those vector databases and retrievers with NVIDIA Nemo and NIMS. And we have a great partnership with Dell. Everybody who is building these chatbots and generative AI, when you're ready to run it, you're going to need an AI factory. And nobody is better at building end-to-end systems of very large scale for the enterprise than Dell. And so anybody, any company, every company will need to build AI factories. And it turns out that Michael is here. He's happy to take your order.
Michael está muy feliz de haber hecho la
Ladies and gentlemen,
petición.
Michael Dell.
De Dell, ¿no?
Okay, let's talk about the next wave of robotics. The next wave of AI, robotics. Physical AI. So far, all of the AI that we've talked about is one computer. Data comes into one computer, lots of the world's, if you will, experience in digital text form. The AI imitates us by reading a lot of the language to predict the next words. It's imitating you by studying all of the patterns and all the other previous examples. Of course, it has to understand context and so on and so forth. But once it understands context, it's essentially imitating you. We take all of the data, we put it into a system like DGX, we compress it into a large language model, trillions and trillions of parameters become billions and billions, trillions of tokens becomes billions of parameters. These billions of parameters becomes your AI.
Y esos
Well,
trillones de tokens se
in order
convierten
for us to
en
go
tu
to the
IA.
next wave of AI, where the
La
AI
siguiente oleada
understands the
es la IA
physical world,
física,
we're going to need 3 computers.
corporizada. Necesitamos
The first
otros
computer is still
computadores.
the same computer. It's that AI computer that now it's going to be watching video, and maybe it's doing synthetic data
Ahora con
generation.
datos de vídeo,
Maybe there's a lot of
datos
human
sintéticos de generación,
examples, just as we have human examples in text form, we're going to have human examples in articulation form,
en forma de
and the
articulaciones.
AIs will watch us,
Nos van a
understand
ver
what is
actuar.
happening, and try to
Movernos.
adapt it for themselves into
Se
the
adaptarán
context.
En un
And because
contexto,
it can generalize with these foundation models, maybe these robots can also perform in the physical world
Estos
fairly generally. So I just
robots se van a
described
desempeñar en el
in
mundo real
very
con
simple
nosotros.
terms essentially what just happened in large language models, except the ChatGPT moment for robotics may be right around
El
the
momento
corner.
ChatGPT para las robóticas todavía
And so we've been
llegará.
building the end-to-end systems for robotics for some time. I'm super, super proud of the work. We have
Estoy muy
the
orgulloso
AI
de este
system,
trabajo.
DGX.
El trabajo
We
de
have
IA
the lower
en
system, which is
DGX,
called AGX, for autonomous systems. The world's first
Los sistemas
robotics
autónomos.
processor. When we first built this thing, people are, what are you guys building? It's a SoC. It's one chip. It's
SoC.
designed to be very low power, but it's designed for
Muy poca
high-speed sensor
energía.
processing and AI. And so if you want to run transformers in a
Si quieres
car, or
ejecutar
you want to run
transformers en un coche,
transformers in a anything that moves, we have the perfect computer for you. It's
Tenemos la
called the
perfecta
Jetson.
computadora para ti.
And so the DGX on top for training the AI, the Jetson is the autonomous processor,
El Jetson
and
es
in the
el
middle,
procesador autónomo.
we need another computer.
Necesitamos otra computadora.
Whereas large language models have the benefit
Los LLMs tienen un beneficio
of
muy
you
grande.
providing your examples
Que tú
and then
provees
doing
tus ejemplos
reinforcement learning human feedback.
Y tiene usado de
What is the reinforcement
refuerzo de
learning
humano.
human feedback of a robot?
¿Cómo
Well,
puedes
it's
reforzar
reinforcement
un
learning
humano a un robot?
physical feedback. That's how
Con
you
un feedback
align the
físico.
robot. That's how the robot knows that as it's
Así el
learning
robot
these
sabe cuando le pega ahí un
articulation
palo, esto no
capabilities
lo
and
has hecho bien.
manipulation capabilities, it's going to adapt properly
Se va a adaptar
into the laws of
adecuadamente
physics.
a
And
la
so
física del
we
entorno.
need a simulation
We
engine
need una simulación,
that
necesitamos una
represents the
simulación
world
física del
visually
entorno.
for the robot, so that the robot
Para el
has
robot, para
a
que aprenda.
gym to go learn how to be a robot. We call that
Lo llamamos
virtual world Omniverse.
un
And the
universo,
computer that runs
un
Omniverse is
universo
called
del mundo
OVX.
virtual.
And OVX, the computer itself, is
OVX.
hosted in the Azure cloud.
Va
Okay?
a
And so
funcionar
basically, we built
en la
these
nube
three
de
things, these
Azure.
three systems. On top of it, we have algorithms for every single one.
Tenemos algoritmos para
Now,
cada.
I'm going to show you one super example of how AI and Omniverse are going to work together. The
Omniverse y-
example I'm going to show you is kind of insane, but it's going to be very, very close to tomorrow. It's a robotics building.
Un edificio de
This robotics
robótica
building is called a warehouse.
llamado el almacén.
Inside the robotics building are going to be some
Dentro de ese
autonomous
almacén
systems.
Va a haber algunos
Some of the
sistemas.
autonomous systems are going to be called
autónomos.
humans, and some of the autonomous systems are going
Algunos
to be called
serán llamados humanos y
forklifts.
algunos serán llamados
And these
robots.
autonomous
Ningún
systems
problema, ¿no?
are going to interact with each other, of course,
Interactuarán
autonomously,
entre ellos,
and
por
it's going to
supuesto.
be overlooked upon by this warehouse to keep everybody
van-
out of harm's way. The warehouse is essentially an air traffic controller.
El
And
almacén
whenever
es
it
un
sees something
controlador de
happening,
tráfico aéreo
it will redirect traffic and
Redirigirá el
give new
tráfico
waypoints.
y
Just
pondrá
new
puntos,
waypoints to the robots and the
waypoints
people, and they'll know exactly what to do.
con gente y con robots.
This warehouse, this building, you
Warehouse,
can also
este
talk
edificio.
to.
Básicamente
Of course
alguien
you
con
can
el que
talk
puedes
to.
hablar.
Hey,
Es una infraestructura.
SAP Center,
Hostia,
how are
esto
you
sí que es
feeling
nuevo.
today?
Es una
For example.
infraestructura. Es un
And so
modelo de
you
ya,
can ask the
infraestructura.
same- the warehouse the
Vale,
same
una infraestructura de ya,
Basically, the
podemos
system
decir.
I just described will have
Puedes hablar con la fábrica.
Omniverse Cloud that's hosting the virtual simulation and AI running on DGX Cloud,
La IA
and all of
corriendo
this is
en
running
la
in
nube
real
de
time. Let's take a look.
DGX. A ver.
The future of heavy industries
El futuro
starts
de la
as a
industria
digital
pesada es
twin.
este.
The AI agents helping robots,
Los agentes de
workers, and
IA
infrastructure
ayudando
navigate
a los robots
unpredictable events
a
in
navegar
complex industrial spaces will
complejo
be
espacio
built and
industrial.
evaluated first in sophisticated digital twins.
Con sofisticados
This Omniverse
dobles
digital
digitales.
twin of a 100,000 square foot warehouse is operating as a simulation environment that
Un entorno de
integrates digital
simulación.
workers,
Es como el Sims, pero de la
AMRs
fábrica.
running the NVIDIA Isaac Perceptor stack, centralized activity maps of the entire warehouse
Mapas
from
centralizados
100
de todo el
simulated
warehouse.
ceiling mount cameras using NVIDIA Metropolis,
Cámaras usando
and
NVIDIA
AMR
Metropolis.
route planning with NVIDIA CoOpt.
Y
Software
planeamiento
in loop testing of AI agents in this physically
testeado de
accurate
los
simulated
agentes
environment
en este
enables us to
entorno
evaluate
simulado.
and refine how the system adapts to
Refinará cómo el
real-world
sistema se
unpredictability.
adapta.
Here, An incident
Estudio de
occurs
tiempos y
along this
movimientos es
AMR's
muy
prime
poca,
route,
es broma,
blocking its
comparación de
path
esto.
as it moves to pick up a pallet.
Aquí enseño a
NVIDIA
ver qué ha
Metropolis
pasado. Bueno, ya
updates
verás
and
robots.
sends a
Yo de
real-time
momento me estoy
occupancy
mirando.
map to co-opt, where a new optimal route is calculated. The AMR is
Se crea una
enabled to
nueva
see
ruta.
around corners and improve its mission efficiency.
Se mejora la
With
eficiencia
generative
del robote.
AI-powered Metropolis Vision Foundation models,
Usando el modelo de
operators
formulación
can
de
even
visión
ask questions using
Metropolis.
natural language. The
¿Ha
visual
oído
model
algo en
understands
la
nuanced
estantería
activity
3?
and can
Sí,
offer
se ha
immediate
colapsado una
insights to
estantería y las
improve
cajas han caído
operations.
y
All of
bloqueando
the
el paso.
sensor data is
Vale,
created
vale,
in
pues venga,
simulation
pues. Ya
and
por ahí no
passed to
vamos.
the real-time AI
por otro lado.
running as NVIDIA Inference
Estás hablando para
Microservices, or
fábrica, ¿vale?
NIMs. And when the AI is ready to be deployed in the physical twin, the real warehouse, we connect
Brutal.
Metropolis and Isaac NIMs to real sensors
Cámara,
with
robots,
the ability for
manos,
continuous
algo de esto
improvement
metido.
of both the digital twin and the AI models.
Isn't that incredible?
Increíble.
And so, remember a future facility,
Una fábrica del futuro,
warehouse, factory,
un almacén,
building will be software defined.
se
And so
está
the
definido por
software is
software.
running. How else would you test the software? So you
¿Dónde testeas el
test
software?
the software, the building, the warehouse,
Lo
the
testeas
optimization system in the digital twin.
el doble
What about
digital.
all the robots? All of those robots you were seeing
Con
just
los
now,
robots,
they're
con los
all
humanos,
running
con
their
todo.
own autonomous
Ve, el
robotic
humano igual
stack.
no se
And so the
ajusta
way
a lo
you
que es al
integrate
doble
software
digital,
in
pero
the
bueno,
future,
del todo.
CI/CD in the future, for
Es
robotic
robots, sí.
systems is with digital twins. We've made Omniverse a lot easier
Hemos
to
hecho
access. We're going to create
Omniverse,
basically Omniverse cloud APIs, 4
APIs
simple
para la
API in a
nube.
channel, and you can connect your application
Podéis
to
conectar
it.
vuestras aplicaciones a
This
ello.
is going to be as wonderfully, beautifully simple in the
Va a ser
future that Omniverse is
tremendamente
going to be.
simple.
And with these APIs, you're going to have these
Una API
magical
USD
digital twin capability. We also
y
have turned
APIs de canal
Omniverse into
Omniverse.
an AI.
USD hemos dicho que era la
with
clave.
the
¿Y qué es
ability
USD?
to
Pues
chat
a ver si lo
USD,
explica.
the language of our language is, human, and Omniverse's language, as it turns out, is universal scene description.
Universal
And so
Scene
that
Description.
language is rather complex, and so we've taught
Descri-
our Omniverse
descripción de
that
escena
language. And so
universal.
you can speak to it in English, and it would
Puedes hablar en
directly
inglés.
generate USD, and it would talk back in
Te
USD,
genera un
would
USD.
converse back to you in English. You could also look for information in this world
Puedes buscar
semantically.
información en este mundo.
Instead of the world being encoded semantically in language, now it's encoded semantically in scenes. And so
Está
you can
codificado
ask it
semánticamente y en
of,
escenas.
certain objects or certain conditions or certain
Objetos,
scenarios,
condiciones.
and it can go and find that scenario for you. It
Puedes
also
ir a
can
encontrarlo
collaborate
por
with
ti.
you in generation. You could design some things in 3D,
Puedes crear algo
it
en
could simulate
3D.
some things in 3D, or you could use AI to generate something in
Puedes usar algo
3D.
de
Let's take a look
IA para
at how
generar
this is
algo.
all going to
Consola,
work.
por
We have a
ejemplo.
great partnership with Siemens.
Tenemos
Siemens is
una
the world's
colaboración con Siemens.
largest industrial engineering and operations platform.
Más grande plataforma de
We've seen now
ingeniería
so many different companies in the industrial space. Heavy industries
También en la
is
industria
one of the
aeroespacial.
greatest final frontiers of IT. And we finally now have the necessary technology to go and make a real impact.
Tenemos
Siemens
la
is
tecnología
building the
necesaria para hacer
industrial
un
metaverse.
impacto.
And today we're announcing that Siemens is connecting their crown jewel
Siemens
accelerator
está
to
conectando
NVIDIA
su joya de
Omniverse.
la
Let's take a
corona
look.
con nosotros.
Siemens technologies transform the everyday for everyone.
Está
Teamcenter
transformando
X,
todos
our
los días
leading
para
product
todo
lifecycle
el
management
mundo.
software from the Siemens Accelerator platform, is used every day by our customers to develop and deliver products
Para
at scale.
desarrollar y distribuir
Now we are
productos.
bringing the real and the digital worlds even closer by integrating NVIDIA AI and
Integrando
Omniverse
NVIDIA
technologies
Omniverse.
into Teamcenter X. Omniverse APIs enable data interoperability and physics-based
Con el
rendering to
accelerator
industrial
de
scale
Siemens.
design and manufacturing projects. Our
Para
customers,
nuestros
HD
proyectos de
Hyundai,
manufactura.
market leader in sustainable ship
Sos
manufacturing,
el líder
builds
de construcción
ammonia
de barcos,
and
por lo veo.
hydrogen powered ships, often comprising over 7 million discrete parts. With Omniverse
7 millones de
APIs,
partes
Teamcenter
distintas,
X
¿eh?
lets companies like HD Hyundai unify and visualize these massive
Unify y
engineering
visualizar
data
esas
sets
masivas
interactively.
cantidades de
Integrate
datos.
generative AI to generate 3D objects or HDRI
Puede generar
backgrounds to
objetos en
see
3D.
their projects in context.
Y usando sus
The
proyectos
result,
en
an
contexto.
ultra-intuitive, photoreal, physics-based digital twin that
Fácil,
eliminates waste and errors, delivering huge savings in cost and time.
Creando amplios
We are building this
ahorros en
for
coste y en
collaboration,
tiempo.
whether across more Siemens accelerator tools like Siemens NX or Star CCM+, or across teams working on their favorite devices in the
Trabajando
same
en sus
scene
favoritos
together.
aparatos para
This is
diseñar.
just the beginning.
Y esto es
Working
el
with
principio.
NVIDIA, we will bring accelerated computing, generative AI,
Llevaremos
and
la
Omniverse
computación
integration
acelerada
across the Siemens Accelerator portfolio.
usando el accelerator de Siemens para ti.
The professional voice actor happens to be a good friend of mine, Roland Bush, who happens to be the CEO of Siemens.
El actor de doblaje de esto, la voz de esto, es un buen amigo mío. Una vez que
Omniverse connected into your workflow,
Omniverse se conecta a tu diagrama de flujo,
from the beginning of your design
tienes a Nissan, por ejemplo,
to engineering,
a la
to manufacturing planning, all the way to digital twin operations.
operando
Once
dobles
you connect
digitales.
everything together,
Conectas
it's
todo
insane
junto.
how much productivity you can get.
Es increíble
And it's
cuánta
just really,
productividad
really
puedes tener.
wonderful. All of a sudden, everybody's operating on the same ground truth.
De pronto todos operan
You
en
don't
el
have
mismo
to
terreno.
exchange data and convert data, make mistakes. Everybody is working on the same ground truth. From the design department to the art department, the architecture department, all the way to the engineering and even the marketing department. Let's take a look at how Nissan has integrated Omniverse into their workflow. And it's all because it's connected by all these wonderful tools and these developers that we're working with. Take a look.
Mismo te hago un coche con unas zapatillas y un bolso. Llega siendo hora de usar la inteligencia generativa para esto, ¿no? Espero que también en las panaderías, por ejemplo.
每一种颜色都能使这款车型焕发出独特的魅力。
我喜欢有质感些的灰色。
非常好的选择。
Excelente elección. Ahora ya lo tienes. Modelos 3D animados de no sé qué tal. Chicago Skyline en unas zapatillas Adidas para adentro. Digamos, esto era lo primero que había que haber hecho, ¿no? Las industrias ya estaban tardando, ¿no? Ahora en extremas condiciones. Bueno, pues nada, te lo creo. Y ahora lo visualiza el cliente en su casa. Hazme un vídeo de publicidad de 20 segundos de Nissan. Vale, ya está. Pues ahora con el bigot, con lo que quiera. Ya está.
That was not an animation, that was Omniverse.
Eso era Omniverse.
Today we're announcing that Omniverse Cloud
la nube de Omniverse
streams to the Vision Pro. And
llega a Vision Pro, claro. Era de esperar.
It is very, very strange that you walk around virtual doors. When I was getting out of that car, and everybody does it. It is really, really quite amazing. Vision Pro connected to Omniverse portals you into Omniverse. And because all of these CAD tools and all these different design tools are now integrated and connected to Omniverse, you can have this type of workflow. Really incredible. Let's talk about robotics.
Flujo de trabajo.
Everything that moves will be robotic. There's no question about that. It's safer, it's more convenient.
Más seguro, más conveniente.
And one of the largest industries is going to be automotive.
Y una de las más grandes industrias será la automovilística. BYD, por
From the computer system, but in the case of self-driving cars, including the self-driving car application.
Tendrás
también At the end of this year,
or
I guess beginning of next year, we will be shipping in Mercedes, and then shortly after that, JLR. And so these autonomous robotic systems are software-defined. They take a lot of work to do. Has computer vision, has obviously artificial intelligence, control and planning, all kinds of very complicated technology, and takes years to refine. We're building the entire stack. However, we open up our entire stack for all of the automotive industry. This is just the way we work. The way we work in every single industry, we try to build as much of it as we can so that we understand it, but then we open it up so that everybody can access it. Whether you like to buy just our computer, which is the world's only full functional, safe ASIL-D system that can run AI, this functional, safe ASIL-D quality computer, or the operating system on top, or, of course, our data centers, which is in basically every AV company in the world.
No he entendido esto bien.
However you would like to enjoy it, we're delighted by it. Today we're announcing that BYD, the world's largest EV company, is adopting our next generation. It's called Thor. Thor is designed for transformer engines. Thor, our next generation AV computer, will be used by
Automatic
BYD.
driving, me imagino será, ¿no? Automatic vehicle.
You probably don't know this fact that we have over 1 million robotics developers. We created Jetson, this robotics computer. We're so proud of it. The amount of software that goes on top of it is insane. But the reason why we can do it at all is because it's 100% CUDA compatible. Everything that we do in our company is in service of our developers. And by us being able to maintain this rich ecosystem and make it compatible with everything that you access from us, we can bring all of that incredible capability to this little tiny computer we call Jetson, a robotics computer. We also today are announcing this incredibly advanced new SDK. We call it Isaac Perceptor.
Isaac Perceptor.
Most of the robots today are pre-programmed. They're either following rails on the ground, digital rails, or they'd be following APRO tags. But in the future, they're going to have perception. And the reason why you want that is so that you could easily program it. You say, I would like to go from point A to point B, and it will figure out a way to navigate its way there. So by only programming waypoints, the entire route could be adaptive. The entire environment could be reprogrammed, just as I showed you at the very beginning with the warehouse. You can't do that with pre-programmed AGVs. If those boxes fall down, they just all gum up and they just wait there for somebody to come clear it. And so now, with the Isaac Perceptor, we have incredible state-of-the-art vision odometry, 3D reconstruction, and in addition to 3D reconstruction, depth perception. The reason for that is so that you can have two modalities to keep an eye on what's happening in the world. Isaac Perceptor. The most used robot today is the manipulator.
El robot más habitual es el manipulador industrial de toda la vida, ¿vale? Eso es.
The computer vision algorithms, the AI algorithms, the control and path planning algorithms that are geometry aware, incredibly computationally intensive. We have made these CUDA accelerated. So we have the world's first CUDA accelerated motion planner that is geometry aware. You put something in front of it, it comes up with a new plan and articulates around it. It has excellent perception for pose estimation of a 3D object. Not its pose in 2D, but its pose in 3D. So it has to imagine what's around and how best to grab it. So the foundation pose, the grip foundation, and the articulation algorithms are now available. We call it Isaac Manipulator. And they also just run on NVIDIA's computers.
Isaac Manipulator.
We are starting to do some really great work in the next generation of robotics. The next generation of robotics will likely be a humanoid robotics. We now have the necessary technology, and as I was describing earlier, the necessary technology to imagine generalized human robotics. In a way, human robotics is likely easier, and the reason for that is because we have a lot more imitation training data that we can provide the robots because we are constructed in a very similar way. It is very likely that the humanoid robotics will be much more useful in our world because we created the world to be something that we can interoperate in and work well in. And the way that we set up our workstations and manufacturing and logistics, they were designed for humans. They were designed for people. And so these humanoid robotics will likely be much more productive to deploy. While we're creating, just like we're doing with the others, the entire stack. Starting from the top, a foundation model that learns from watching video, human examples. It could be in video form, it could be in virtual reality form. We then created a gym for it called Isaac Reinforcement Learning Gym, which allows the humanoid robot to learn how to adapt to the physical world. And then an incredible computer, the same computer that's going to go into a robotic car, this computer will run inside a humanoid robot.
Esta computadora irá dentro de un robot humanoide o de un coche. Es lo mismo.
We've combined several of these into one video. This is something that you're going to really love. Take a look.
Esto es algo que os va a encantar. Mirad.
It's not enough for humans to imagine.
Es suficiente que los humanos imaginen.
We have to invent.
Tenemos que inventar.
And explore.
Y explorar.
And push beyond what's been done.
Forzar los límites de lo que se ha hecho. De lo que puede hacerse.
We create smarter.
Creamos más inteligentemente y más rápidamente.
We push it to fail.
Y también fracasamos.
So it can learn.
Y aprendemos. Toma para.
We teach it.
Nos enseñamos.
Then help it teach itself.
Y le ayudamos a aprender
We broaden its understanding.
Incrementar su entendimiento.
To take on new challenges.
Para llevar a cabo nuevos desafíos.
With absolute precision.
Con precisión absoluta.
And succeed.
Y triunfar.
We make it perceive.
Hacemos proceder.
And move.
Y moverse.
And even reason. So it can share our world.
Para compartir nuestro mundo con nosotros.
This is where inspiration leads us.
Esto es a
the next frontier.
Nos lleva a la inspiración, a una nueva frontera.
This is NVIDIA Project Groot. A general-purpose foundation model for humanoid robot learning.
General para robótica.
The Groot model takes multimodal instructions and past interactions as input and produces the next action for the robot to execute. We developed Isaac Lab, a robot learning application to train Groot on Omniverse Isaac Sim. And we scale out with Osmo, a new compute orchestration service that coordinates workflows across DGX systems for training and OVX systems for simulation. With these tools, we can train Groot in physically based simulation and transfer zero shot to the real world. The Groot model will enable a robot to learn from a handful of human demonstrations, so it can help with everyday tasks. And emulate human movement just by observing us. This is made possible with NVIDIA's technologies that can understand humans from videos, train models in simulation, and ultimately deploy them directly to physical robots. Connecting Groot to a large language model even allows it to generate motions by following natural language instructions.
Hi, GOI. Here, give me a high five?
Lenguaje natural.
Sure thing. Let's high five.
Y
Can you give us some cool moves? Sure. Check this out.
Con acciones, vale. Esto
All this incredible intelligence is powered by the new Jensen robotics chips, designed for Groot, built for the future.
Si piensan y se mueven, ¿están vivos o no están vivos? Que me lo expliquen.
We're providing the building blocks for the next generation of AI-powered robotics.
No te puedo decir más. Esto viene. Así bien. Ahí tienes toda la panoplia, ¿vale? Ahí los tienes. Esto es lo que lo está petando ahora. Mira, viene el de Sanctuary también. Ahí lo tienes a la derecha. A la izquierda el de Amazon. Creo que es de Amazon. Yo me quedo con el Figure. Eso es para mí.
The soul of NVIDIA.
El alma de NVIDIA.
The intersection of computer graphics, physics, artificial intelligence.
Computación gráfica,
it all came
física,
to bear at
pero
this
ahora viene
moment.
lo nuevo.
The name of that project, General Robotics 003.
Robótica de funcionamiento de uso generalista.
Super good.
Muy bien.
Well, I think we have some special guests.
Tenemos que algunos invitados especiales.
Do we?
Joder, menos mal que mucho hemos tardado. Mucho estamos tardando, que es que llevamos las 2 horas ya.
Hey guys. So I understand you guys are powered by Jetson. They're powered by Jetsons. Little Jetson robotics computers inside. They learn to walk in Isaac Sim.
Aprendieron a andar en el simulador de Isaac.
Ladies and gentlemen, this is orange, and this is the famous green. They are the BDX robots of Disney.
Son robots
Amazing Disney research.
Cuando te lleguen los animatrónicos vas a flipar.
Come on, you guys, let's wrap up.
Esto no es nada en
Let's
comparación.
go. 5 things. Where are you going? I sit right here. Don't be afraid. Come here, Green.
No te vayas,
Hurry
mira.
up.
Ven, el naranja y el verde. No quiere.
What are you saying? No, it's not time to eat.
No es momento de comer todavía.
It's not time to eat. I'll give you a snack in a moment. Let me finish up real
Trae
quick.
algo para comer.
Come on, Green, hurry up.
Venga, verde,
Stop
vete para acá.
wasting time.
Estamos gastando el tiempo,
5 things. 5 things.
5
First,
cosas. Primero,
a new industrial revolution.
una nueva revolución
Every
industrial.
data center should be accelerated. $1 trillion worth of installed data centers will become modernized over the next several years. Second, because of the computational capability we brought to bear, a new way of doing software has emerged. Generative AI, which is going to create new infrastructure dedicated to doing one thing and one thing only. Not for multi-user data centers, but AI generators. These AI generation will create incredibly valuable software.
Creando
A new industrial revolution.
una nueva
Second,
revolución
the
industrial.
computer of this revolution, the computer of this
Tiene razón
generation,
aquí el amigo Carl Schwab.
generative AI, trillion
Esto iba serio,
parameters,
Esto no era conspiranoia,
Blackwell, insane amounts of computers and computing. Third, I'm trying to concentrate.
Me trato de concentrar.
Good job.
Buen trabajo.
Third,
Tercero,
new computer creates new types of software.
Nuevas
New type of
computadoras
software
crean
should be
nuevos tipos de
distributed
software.
in a new way so that it can, on the one hand, be an endpoint in the cloud and easy to use, but still allow you to take it with you because it is your intelligence. Your intelligence should be packaged up in a way that allows you to take it with you. We call them NIMs. And third, these NIMs are going to help you create a new type of application for the future. Not one that you wrote completely from scratch, but you're going to integrate them like teams. Create these applications. We have a fantastic capability between NIMs, the AI technology, the tools, NeMo, and the infrastructure DGX Cloud in our AI Foundry to help you create proprietary applications, proprietary chatbots. And then lastly, everything that moves in the future will be robotic. You're not going to be the only one. And these robotic systems, whether they are humanoid, AMRs, self-driving cars, forklifts, manipulating arms, they will all need one thing. Giant stadiums, warehouses, factories. There can be factories that are robotic, orchestrating factories, manufacturing lines that are robotics, building cars that are robotics. These systems all need one thing. They need a platform, a digital platform, a digital twin platform.
Una
We call
copia,
that
un doble
Omniverse,
digital.
the operating system of the robotics world.
El sistema operativo del mundo
These are the 5
robótico.
things that we talked about today.
Y esto es de
What
lo
does
que hemos
NVIDIA
hablado
look
hoy.
like? What does NVIDIA look like?
¿Qué
When we
parece
talk about
NVIDIA
GPUs, there's a very different image that I have
una
when
imagen muy distinta a la que
people
tenemos
ask me
ahora.
about GPUs.
Cuando me hablan de
First, I
GPUs
see a
ahora,
bunch of
¿verdad?
software stacks and things
Ahora
like
es
that. And
distinto.
second, I see this. This is what we announced to you today.
Esto es lo que
This
te
is
anunciamos
Blackwell.
a ti hoy,
This
a
is
vosotros
the
hoy en día. Plataforma de NVIDIA Blackwell.
Amazing processors, NVLink switches,
Increíbles procesadores,
networking
switches,
systems, and the
sistemas de
system
red.
design is a miracle. This
Y esto, diseñar
is
esto es un
Blackwell.
milagro.
This to me is what a GPU looks like in my mind.
Esto para mí es lo que es un GPU en mi mente.
Listen, orange, green,
Escucha,
I
naranja,
think
verde.
we have one more treat for everybody. What do you think? Should we?
Tengo algo más para la gente. ¿Qué
Okay,
opinas?
we have one more thing to show you.
Una última cosa que
Roll it.
enseñaros. Corre. Muéstrame tecnologías de Nvidia. Asistente a bordo. Sí, ejecutar. Centro de datos, servidor. ¿Quieres que iniciemos el autopilot Neva? Todavía alguien se plantea lo que si, dónde está la superinteligencia, porque es que es verdad, pobrecitos míos. Ahí cuando llega la baja, no la estás viendo a tu alrededor. ¿Qué te crees que esto se ha hecho solo? Pues sí. ¿Te crees que esto lo ha hecho un humano? Los humanos solos. Pues no. Lo están diciendo, lo están optimizando por medio de ella. ¿No te parece suficientemente inteligente crear nueva tecnología de la nada? No le parece usted inteligente. Estas criaturas que viven, máquinas cuánticas que respiran, robots que se mueven y que piensan solos, ¿no le parece suficiente vida? Es que no es suficiente. Ay, ojalá ya encontremos extraterrestres. Digo, ¿te parece poco lo que tienes aquí, hijo mío? ¿Te parece poco lo que tienes? Magia biodigital. Potenciando la nueva era de computación. Ya, callar.
Thank you. Thank you. Have a great GTC. Thank you all for coming.
Gracias por venir. Esto en Europa se sufre. ¿Por qué? Pues porque ya es de noche. Ahí todavía no debe ser la 1 o concretamente las 3. Era la 1 cuando arrancó. Pues calcula. Yo con esto no te puedo decir más. Un saludo y hasta pronto. Y a ver cómo lo subimos a BitChute, que vas a flipar.